Well, good morning, everyone, and welcome back to day 2 of the Esri Imagery and Remote Sensing Educator Summit. I'm Laurie Jordan, Corporate Director of Imagery and Remote Sensing.
And I'm Jerry Miller, Director of Education at Esri and faculty at Johns Hopkins University. And we look forward to being with you today and continuing some of the wonderful discussions.
Great, thanks, Jerry. And yes, for the benefit of our colleagues who weren't able to join us yesterday, let's start by doing a quick recap of the goals of this summit. So an overarching desire of the team that designed this was to really provide a forum for the members of the academic community to share not just with us, but particularly with each other, remarkable progress, success stories, and projects that are happening throughout higher education in imagery and remote sensing. And during this time of pandemic, of course, there are a number of challenges that educators are faced with, particularly in remote learning environments. There are continuing issues and challenges that we struggle with. How do we increase diversity in the workforce that we're training to be the future leaders of our profession? And also, for example, this tidal wave of new software capabilities that continue to come out across the board. Is a very, very fertile and innovative time at Esri for imagery and remote sensing, and we're going to be showing you for the first time some of the brand new tools that are coming out today with our product manager, Peter Becker, for imagery. And it's quite remarkable capabilities that you're going to be very interested to see. This is also going to give you some context throughout the day to provide some answers to questions as a way of giving us your input and feedback so that we can tailor our roadmap and our development plans to make sure that we're being of service to you. Perhaps probably most importantly here at the end, an opportunity to learn from each other as we all aspire to be students for life, part of lifelong learning. So Jerry, I know you have a very content-rich agenda that you're anxious to share with us today. Tell us a little bit more about that.
Absolutely, Laurie. So we have a wonderful day with lots and lots of interesting sessions, and we look forward to some productive discussions. We have our lightning talks that are going to be similar to yesterday, but today's are going to be a little bit more focused on research work that is taking place. And after these lightning talks, we'll have a series of questions and answers. So as we go through all of these sessions, we do encourage you, similar to what we did yesterday, ask as many questions as you can in our Q&A tool in the Zoom webinar. Then we'll proceed with how the Academy works with Esri sessions. So there are a couple of special sessions here. And it's interesting when, yesterday, I think maybe we have confused some folks in terms of this term Academy. Well, we're talking with Laurie yesterday, and he mentioned that Jack likes using the word Academy. And really what we mean by that is the education community, academic community. So what this session is going to be about is how the academic community works with Esri. We get lots of questions from community that pertain to things like, how do I get access to Esri technology? Or I know I already have it on campus, but who do I go to for help and support? Or what is included in the education program that my institution has? Or what are some of the resources that are available to me as an educator that can help supplement some of my work? So we'll take a look at some of these questions and then have a discussion about them. And we'll have a special session on what's new with Esri Imagery and Remote Sensing. So Peter Becker, our product manager for Imagery and Remote Sensing, is going to facilitate this for us. And then if you recall, yesterday we had 3 different working groups on 3 broad topics of drones, 3D imagery, as well as GeoAI. So we'll come back to those topics. We'll sum up some of the results and continue the discussion. And then we'll finish with a closing session and a panel that Dr. Dawn Wright is going to moderate for us. And we'll, of course, reflect on everything that has happened and address any outstanding questions. So before we move on to the lightning talks, we wanted to mention some of the resources that are available out there. And as we go throughout the day, we'll keep referencing some of these resources and have further discussions about them. I'm going to share a couple of items there. On the event page, there is a resources link, so event resources that have a number of different sections. So a few trainings and tutorials that are available, and a little later, we're going to extensively cover this first one. So the imagery and remote sensing learn ArcGIS materials that are specifically designed for educators, that contain activities, that contain slides, and so on. So Delphine Kana from the Learn ArcGIS team is going to share some of this wonderful work with us. We have a MOOC that is coming up that begins August 11th. So we're highly encourage you to take a look at it. And again, logins completely free to anyone globally. So feel free to take advantage of this wonderful offering. Another one is the Learn ArcGIS site. So the same team that produced the imagery and remote sensing curriculum, I'm going to switch over here for a second. In case you have not seen it, there's lots and lots and lots of other lessons and tutorials that can, again, supplement some of the work that we're doing. And then obviously as educators, we'll take it a step further, but there's a special section on imagery and remote sensing, special section, spatial analysis, data science, and so on and so on. So lots and lots of lessons. Of course, Esri training. So some of you might recall from yesterday, there were quite a few folks that have been using ArcGIS technology for a while. If you remember the old virtual campus. So now it's the Esri Academy. It's the e-learning courses that we have, tons of web courses, instructor-led courses that are available as well. So we highly encourage you to take a look at those. And there's lots of wonderful, wonderful items that we can pick and choose from there that would help supplement some of the stuff, the curriculum that we're teaching or the work that we're doing in general. Another resource, there's a landing page for imagery and remote sensing in higher education that again has a number of different sections there in terms of tools to use, learnings, curricula, various webinars that we have done, various success studies of how imagery and remote sensing technology has been used and has been leveraged. I'd also like to point out to the Esri Press books that are on there's a link to a few of these books on the main resources page for the event. Lots and lots of options there. If you are one of those educators who is leveraging books, there's one for imagery and GIS. There's quite a few other ones that are there. And as hopefully you know, as educator, you do get what we used to call the desk copy. So you can get free books to take and to evaluate for use in your own class. And we use Vital Source as a vendor to go and to request some of those book resources. And lots of other items here. I'm not going to go over all of them, but I will mention one more, and that is the Esri community and lots of different blogs and resources that are available through it. So many of you, I'm sure, hopefully know of GeoNet, and we kind of revamped it, retitled it to the Esri community. And it's a wonderful resource that you can go and rely on, ask questions, have a discussion with product experts, and with, of course, various other industry specialists that we have. So we have things grouped by products, things grouped by industries. There's a special section for education as well. So again, lots of different resources to get us started. And all of these are produced, of course, with when we think about some of these resources, especially some of the education pages are with the educator community in mind. So with that said, again, as we go through, we'll even cover further resources, especially some of the working group results one, but this hopefully kind of gets us going with some wonderful information and things that we can refer back to. So now we'll proceed with our lightning talks, and similar to yesterday, we'll have about 5 of them. Each of them are 5 to 10 minutes long. And after the lightning talks, we'll have a nice Q&A discussion, and a few of those individuals and fellow educators are going to join us. And just like yesterday, Nigel Brown, so I see Nigel came on video already, so he's going to moderate this session for us.
Yeah, Jerry, I'm just amazed at the resources that you have available for the academic communities. You probably need to take a few breaths now just to catch up with all that you presented there. Being relatively new into Esri, it's opening my eyes to just the great support that you and your team does. So I'm very impressed, so thank you. But great, let's move on to today's lightning talks. We had 5 great talks yesterday. We have 5 equally impressive presenters that are going to do their lightning talks today. Our first lightning talk, we go to Beaufort, North Carolina and Duke University, where we'll hear from Maddie Hayes.
My name is Maddie Hayes, and I'm a research technician at the Duke Marine Robotics and Remote Sensing Lab. And I'm here to talk about drones, deep learning, and seabirds. This project was a collaboration between the Mars Lab and the Wildlife Conservation Society down in Argentina. We wanted to see if we could utilize high-resolution drone imagery and deep learning to count colonial seabirds, specifically the black-browed albatross and southern rockhopper penguin, at large mixed colonies. While seabird population dynamics have proven to be successful indicators of ecological change, they often breed in large numbers at inaccessible locations, closely aggregated together, presenting challenges for traditional ground-based surveys. The motivation for this work was to develop an automated method that could increase capabilities for seabird monitoring without sacrificing quality or accuracy. So the study site was down in the Jason Islands, which are in the Northwest Falkland Islands. The Falkland Islands are home to the world's largest breeding population of black-browed albatrosses and the world's second largest breeding population of southern rockhopper penguins. All drone imagery was collected with a DJI Phantom. Imagery at sites 1 and 2 was collected in 2018, while the other 10 sites were flown in 2019. It's also important to note that southern rockhopper penguins are patchily distributed within large black-browed albatross colonies. So the sites on this map that we collected drone imagery of are based on black-browed albatross colony boundaries. We ended up with a total mapped area of 1 square kilometer and around 10,000 individual drone images, which were processed into 12 separate orthomosaics. The 2018 imagery had a resolution of 5 centimeters per pixel, and the 2019 imagery had resolutions ranging from 0.5 to 1.5 centimeters per pixel. So separate models were generated for albatross and penguin detections, but the workflow was the same. The 12 orthomosaics were split into smaller tiles, and about 1/3 were manually labeled for both species. The manually labeled tiles were then split into training, validation, and testing data. We used the Keras implementation of the one-stage object detection architecture, RetinaNet, which is composed of a ResNet 50 feature pyramid network backbone, plus 2 branches for classification and bounding box regression. The albatross model was trained with 12,000 samples and took 3 hours, while the penguin model used around 25,000 samples and took 4 hours to train. The models were then deployed on all the tiles, and these detections were converted to georeference shapefiles. The shapefiles were then exported to ArcGIS to be overlaid on the orthomosaics. The albatross model had an accuracy of 96%, and the penguin model had an accuracy of 87%. For both models, 90% of the automated counts were within 5% of the manual counts. The first model detected 268,764 individual black-browed albatrosses, which is a representative count of all the colony areas on both islands. The second model detected 68,779 individual southern rockhopper penguins. We were not able to detect penguins in the lowest 5 centimeter per pixel imagery from 2018, so this number is not a representative count of all the colony areas. We also looked at the time savings between the two methods. Within this same chunk of 0.5 square kilometer imagery, both models cut down detection time to less than 10% of manual analyst time. These are a few examples from the albatross model. The 2 errors at the bottom are in the lower 5 centimeter per pixel imagery, where the model mainly detected other seabirds or rocks as albatross. And these are a few outputs from the penguin model. The imagery on the right side was the lowest resolution that we were able to detect penguins at, and it's hard for the human eye to even pick up on them, so this is going to be a limitation for the computer as well. And the main error in this model was that it missed quite a few penguins throughout all of the imagery. And this is an example of a successful detection from both models and shows how closely aggregated these seabirds are. Because southern rockhopper penguins nest within black-browed albatross colonies, it can be difficult to get accurate ground counts. The overhead aerial view of these seabirds from the drone imagery can significantly decrease the errors introduced from ground level surveys. This is a great example of that. Using the high resolution imagery makes it very clear where the penguins are within the larger albatross colonies. This project differs from previous work in that we ran detections on the orthomosaics instead of the individual images. This is unique and particularly enabling when investigating large colonies such as those found on the Falkland Islands. It provides opportunities to link focal bird locations with broad habitat features, allowing us to explore patterns and processes of individual organisms and how they interact with the larger ecosystem. With this type of information, we can use geospatial analysis techniques to determine how many breeding pairs of penguins there are based on distance between individuals. We can look at breeding versus non-breeding individuals and quantify occupied nests versus empty nests. So while our study indicates that this automated drone method is a feasible option for seabird population monitoring at large mixed colonies, there are, of course, a few other factors to consider. Integration of this automated method will require duplicate counts using the new drone method and the traditional ground-based method to determine the true ratio of the magnitude of traditional counts to drone counts. Once this ratio is determined, we can start to monitor long-term population variability. Our results also provided useful considerations for future drone flight planning. Both models cannot detect birds below a certain resolution threshold, and while flying lower to the ground may introduce disturbance for more mobile species, we did not see any significant disturbance in even the highest resolution imagery, indicating that we should ideally collect this imagery at around 1 centimeter per pixel to increase accuracy without significantly increasing error. But overall, the results of this study indicate that drone imagery coupled with deep learning can significantly increase the capabilities of population monitoring at the Falkland Islands and beyond. That's all I have for now. Thank you for listening, and feel free to reach out if you have any questions or just want to chat more about this.
Maddie, thank you. What an excellent presentation. A great way to start this morning's lightning talks. What an interesting project, and obviously great use of machine learning algorithms, not only saving hours in manual inspection, but probably saving a few people's eyesight along the way. And with such high accuracy rates, it looks like you've got a very viable model there for ongoing monitoring of the bird population out there in the Falklands. So thank you. I shall probably add this to my list of very cool machine learning applications of remote sensing, which coincidentally includes finding seals on icebergs from space. So great talk. We move on now to Los Angeles. We're joined by Warren Roberts from the Rio Hondo College. Thank you.
My name is Warren Roberts. I'm at Rio Hondo College in Los Angeles County. And this is an exercise that I'd like to share that we performed last year after students were unable to access the lab on campus. We had to look at other measures to permit students to complete lessons. The objectives were to process imagery and extract features to determine distribution patterns. And in this case, we were using ArcGIS Pro. In this exercise, we wanted to make it available to where students could perform the lesson online or locally using some tools that can be performed on both Windows or Mac. So the question here is, how can we perform this? So normally what we do is we provide them imagery like I have here of Joshua Tree. This is captured at about 150 feet and processed using Pix4D. And from here, we would have them identify where the Joshua trees are and determine the distribution patterns. And there are a variety of different tools we can use, both with Esri and other sources. So what we looked at was using the Pix4D online cloud and processed the orthomosaic. And then with the orthomosaic, we wanted to use some tools and extract features. We found that Pictera permitted us to upload the orthomosaic. And this exercise here will walk you through if you want to go through it yourself. So in this exercise with the Joshua trees, the tools we used were ArcGIS Pro. And we processed the imagery using Pix4D. In ArcGIS Pro, we generated tools to classify features and extract, in this case, Joshua trees. And then using some of the distribution analysis tools, we determined what is the distribution pattern. And here is a view of the Joshua trees. And you can see there's a mixture of a creosote, yucca, and then this is a Joshua tree. And going through the tools, we're able to generate these points. So in this case, we decided to use molehills. And my colleague, Don McFarlane, is an ecologist. We do research together over the years. And he is a fan of Harry Potter. And he was out at a field in England doing some research and saw that there were a number of different features in the field. And one of those features that was prominent was the molehills. So he figured this would be a great exercise. So he captured the data and provided me the data for this lesson. And I'll walk you through the steps. And again, this link here will allow you to do the same thing. So we're going to use the Pix4D, and then we're going to use Pictera. And then we're going to use a free tool that we can download called PAST. And I'll demonstrate that briefly. So if you're unfamiliar with orthomosaics, it's where we take multiple images which have a location. In this case, from a drone, has the X, Y, and Z, and any angle from which the camera was in flying. And we can generate a accurate measurement of features from directly above, unlike the perspective view here on the right. On the left here, you can see this is the perspective view. On the right here, this is the orthomosaic generated from, I think in this case, 705 images. This is at Rio Hondo College with students of mine in July 2019 for GS 130. So that was performed using Pix4D. And Pix4D you can install locally. You can also use Drone to Map, Esri. So I obtained the data from this gentleman, Professor McFarlane, and he collected the data using a DJI Spark at 150 feet. And he collected the data, brought back the SIM card from the drone, and then I assembled a lesson. If you want to do any of this professionally, of course, you need to have your FA 107 license in the United States, and that's relatively easy to do. So in this case, if you want to go through the lesson, you can download it here and upload it to Pix4D. You can make a temporary free account. And then going through the process is pretty straightforward. You can see I have a demonstration right here. It will give you an orthomosaic image far better than what you probably find like here in the background on Google Earth. And you can examine what the results look like here on Pix4D Cloud. You can see there are the molehills. You can even see there are some horseshoe prints going through here. So once it's processed, you download the GeoTIFF. And then we upload to a service called Pictera. And again, this is entirely up online. You make a temporary free account. There's a short guide here how to use it. And you can see me performing the same lesson. The idea is to identify what is a molehill and what is not a molehill. Essentially, you are training an artificial intelligence dashboard. And the result will be features you can download, actually shapefiles. And in my case, I determined there were 108. You may have 200. It really depends on how you train the dashboard. And you can see examples of where they're using this up online. Finally, then I downloaded the shapefile of these points, of these molehill locations. And I then downloaded and installed PAST. It's a statistical tool, free, very powerful, and can run on a Mac or a Windows computer. And uploading into the software the XYZ locations from the shapefile, it generated a pretty impressive statistical tool that normally I'd be using ArcGIS Pro. And here you can see the demonstration of me performing the exercise. If you want more information, here's my email and here's our website.
Warren, thank you. In just 8 minutes there, you took us on quite a journey from Joshua trees to molehills and Harry Potter, from drone capture to Pix4D, and from Picterra to ArcGIS, and of course, everything presented within Story Maps. Thank you for an excellent presentation. Now let's head to Wolfsburg, Germany, and hear from Professor Melanie Brandmeier.
Hello, everybody. My name is Melanie Brandmeier. I'm professor of geoinformatics and remote sensing at the University of Applied Sciences in Würzburg. And I'm very happy to be here today and to present some of our latest research. I'm going to show my screen for you. Okay, now you should be able to see my slides. I'm going to talk about artificial intelligence for Earth observation, and in particular about using deep learning on Sentinel-1 and Sentinel-2 data to map deforestation and land cover. Now you can see on this slide how the deforestation rate developed between 2004 and 2019. And we see a decrease in the beginning, but in 2019, the deforestation rate is unfortunately back to 10,000 square kilometers, which is very devastating, of course. And you can also see this on Landsat data and airborne data, massive destruction of the rainforest, which has really huge effects on biodiversity and climate. And actually, the Sustainable Development Goals of the United Nations state that we should halt deforestation and implement sustainable forest management by 2020, and the opposite is unfortunately happening. But there are two recent developments that give new chances, new opportunities for research, for monitoring. And this is, for example, the Copernicus program of the European Space Agency with the Sentinel-1 and Sentinel-2 data that is freely available for everybody. And the second development is huge advances in computer vision technology that are slowly adapted to remote sensing, as you can see here in terms of citations and publications. In green, you see the publications in remote sensing in the field of deep learning. So we're investigating whether we can use convolution neural networks for this task, and in particular, weakly supervised learning, which means that we don't have very good labels. So our study area and data, we have 50 Sentinel-2 multispectral data sets in the Amazon area And in addition to that, we have 24 Sentinel-1 radar data sets that represent 2 time series. The labels are from the Map Biomas project that were derived themselves from Landsat data and extensive field work, which means that they are not accurate everywhere, that they might be wrong in some places. And this is what we mean by weakly supervised learning, that we try to train a deep learning network on this kind of labels and still get robust results. Now, our methodology is based on the ArcGIS platform technology and the Snap tool, which is an ESA software that we used for pre-processing the Sentinel-1 radar data. Now, I will skip the pre-processing part for reasons of time and go directly to the experiments we conducted. And this is the testing of different architectures. So we used UNet and DeepLab, like very common architectures. UNet was developed originally for medical image segmentation by Ronneberger et al. Use a fully connected network, and DeepLab just becoming very popular in remote sensing. And we also invented our own architectures that contain some long-term, short-term memory blocks that are particularly suited for time series. The second experiment was testing different data sets. So we wanted to see how good is the performance using only Sentinel-2 data and how good is it using radar data in addition to the spectral data. For the radar data, we also investigated how the spectral signature changes between the classes. And we see that the biggest differences actually are in the vertical horizontal polarization between June and November. So we also tried to only use these bands. The last problem is class imbalance and our inaccurate labels that we tried to address a bit using a weighted loss function and different loss functions, but these problems are very hard to address. We computed on the Amazon cloud and the Leibniz Supercomputing Center, and I'm going to show you some preliminary results to wrap up. So in terms of data combinations, we see very good results using only the multispectral data on the fully connected network and UNet. If we add some Sentinel data, Sentinel-1 radar data, results don't change a lot, but if we use 34 bands, we also get very good accuracies. Now, on the testing data set, using an independent data set to calculate the final accuracies, we see this again, that UNet has the best performance, but there's almost no difference between DeepLab and Deep Forest in the end. That includes the radar time series. Now, so far, this is only numbers, but let's have a look at the classes and the confusion matrix. We can see that the accuracy is very good for UNet, but there are some classes that the spectral data cannot really capture, in particular some agricultural classes, because we only have one data set, one temporal step. And the problem is that it's very hard to get Sentinel-2 data for the Amazon region because we have pervasive cloud cover. Now, if we add the radar data, we can see that we improve on these classes, the agricultural classes, and Sentinel-1 doesn't have this problem. We can get this data around a year because it just penetrates through clouds. Now, the final thing we wanted to know is how does this look qualitatively? And for this, we do the inference in ArcGIS Pro. And we see the radar phase color image on the left-hand side, the labels on the right-hand side. And now we see the results for UNet for this area. And as I already said, we can see these misclassifications in the agricultural classes, even though the accuracy is very good. This improves a lot if we add the Sentinel-1 data. You can see that these areas are now mostly correctly classified. However, we get some misclassification to urban infrastructure in the northern part of the image. If we look at a high resolution image in this area, we can see that actually there are some dust roads in this area that these feature extractors might recognize as urban infrastructure. And this means that sometimes the deep learning architectures might predict better than our ground truth labels that are inaccurate. And sometimes, of course, it will still be wrong. So our conclusion so far is that deep learning is really an excellent tool for some remote sensing tasks, especially for this large-scale monitoring and mapping, but there's still a lot of research to be done to find the ideal architectures. And we also need a lot of labels and good labels if we want to have good performance. And there are also computational limits in terms of GPU, RAM, and storage. It's a cloud computing problem. And especially some state agencies, they don't have access to this kind of infrastructure. So with this, I am at the end of my presentation, and I would like to thank you for your attention. And I also want to take this opportunity to thank Aya Sharif, master student. She was working very hard on this project to conduct these experiments, and I'm very happy that she now goes on doing a PhD in this field at Leipzig University. So thank you again, and goodbye.
Melanie, thank you so much. A subject near and dear to all of us is the protection and monitoring of the rainforests. And clearly your research with the addition of SAR and AI to traditional optical imagery makes such a difference in how we can monitor the rainforests. We're also delighted to have partners at Esri like Planet, who support the academic and research communities with non-commercial research and academic licensing. And something that I'm particularly looking forward to over the next 2 to 5 years is the opportunity to see close to near real-time monitoring capabilities with SAR partners like Capella and IRSES. We're going to stay in Europe, this time moving to Austria. I'd like to introduce you to Dirk Tiede at the University of Salzburg.
Hello everyone, my name is Dirk Tiede. I'm an associate professor at the Department of Geoinformatics at the University of Salzburg in Austria. I did this work together with some of my colleagues. You see the names on the slide. We teamed up with our spin-off company Spatial Services for a mask RCNN-based building extraction from very high-resolution satellite data in operational humanitarian action. That's an example related to COVID-19 response in Khartoum, Sudan. Doctors Without Borders, MSF, requested in April 2020 a recent map of dwelling density distribution across the city of Khartoum. They supporting their hospitals and clinics, providing care to COVID-19 patients. We worked on a Pléiade 1A image from 2019 November, which were punch sharpened to 0.5 meter ground sampling distance. Roughly 800 square kilometers were covered by this. We use convolutional networks in this approach because they have shown successfully their capabilities in object extraction, especially because they incorporate spatial context in the analysis and do not work only on the pixel level. The biggest challenge here was to get enough samples to train the networks in a short time frame for timely delivery of the map and an accuracy high enough for the support of humanitarian operational work. We use the mask RCNN approach as implemented in the Python API for ESRI's ArcGIS environment. This allowed us to have everything in one place, so pre-processing, sample collection, classification, post-processing, but also the map production. So for a seamless workflow to have also some time saved in the production process. To generate enough training samples, we followed a parallel approach. We had 2 trained image analysts. They digitized dwellings on image subsets for different building footprints, larger and smaller ones. In parallel, a mask RCNN network was trained using this growing sample database. The initial results of that network were checked and validated again by the interpreters, and the positively evaluated ones were then added to the growing sample database without additional digitizing work. You see that here in that workflow. that we trained in parallel the model, put the results back to the interpreters, they were validated, and then again used to retrain our networks. Three models were trained. One model for small dwellings using training sample augmentation, here a rotation by increments of 10 degrees. A second one for larger dwellings without augmentation, because first results showed that augmentation did not increase the accuracy. We think that's based on the shadow casted by the building. The directed shadow were more an asset in the delineation process, so we did not do an augmentation here. And the third model was done for very dense building blocks, where the small dwellings were attached to each other and could not be very well delineated with the first model. So an additional indication for very dense, populated and built-up areas in the city. You see in the table the dwellings which were used in the final training of the model before augmentation took place. So these are the training samples first digitized, initial analysis was done, then they were validated by the interpreters, and this was the final number used in the final models. You see that also here depicted in the map, in bluish color the small dwellings, in yellow color the larger ones, and in red color the building blocks. You see here the results for parts of the city. These are the extracted dwellings, now categorized in 6 different categories. The last one, the other buildings, is done in a post-processing step. All the other categories are only based on the size of the extracted dwellings. In addition, you see here in red color the extracted building blocks indicating very dense areas where these small dwellings are attached to each other and cannot be separated very well. After the post-processing steps using standard GIS routines and the removal of very small dwellings, we ended up with 1.2 million dwellings, 900,000 small dwellings, and roughly 300,000 large dwellings, plus 20,000 of these dense building blocks indicating these very dense settings. For the accuracy assessment, 355 cells of 50 by 50 media were randomly selected, and the dwellings were manually delineated by mapping experts not involved in the studies. You see here on the right the figures. The number of buildings is quite similar. Extent of area covered by buildings seems also to be a very good match, but the spatially explicit match is not perfect. Nevertheless, we reached quite high values for precision recall and F1 score of 0.78 roughly, which shows a good balance between the two various aspects of the error. If you have a closer look at the selected validation cells, you see here in the figure on the left side in green the manually independently delineated dwellings, and on the right in bluish colors our automated extraction. You see that there are some problems in very dense areas like here or here, where our approach generalized a bit too much and smaller dwellings were incorporated in bigger ones, for example. This underestimation of dwellings in very densely built up regions is a finding we already noticed in the first feedback cycles. Therefore, we did this additional building block delineation to indicate where these areas are. First results were available after 10 days, and then we did some more detailed analysis and final map production a few days later. Manual refinement took place before the maps were delivered to the users. We produced 2 final maps. The first one is a dwelling density map, upper part of the figure, where dwelling area has been aggregated to 1 hectare sized hexagon grids. And in the lower part of the figure, the extracted dwellings were shown using the 6 different size categories you have seen in the results. To conclude, the iterative sampling strategy in our workflow helped to reduce time in the training sample production process significantly, and we could also react to limitations identified already in the early stages of the workflow. In such an operational setting, it's always a trade-off between the accuracy you want to reach and the time you need for the training sample production. At the end, you have to match the user expectations, which we did in this example. We extracted almost 1.2 million dwellings, which could not have been reached by other methods in such a short time frame. The ultimate goal is still to have a trained network at hand that convincingly perform with less or no additional sampling, even if you transfer that to other data sets. There's some more future work needed to elaborate on the reuse and improvement of existing models. Thank you very much for your attention.
Well, Dirk, congratulations. Not only was it great to see that you're able to provide, what was it, over 1.2 million building footprint information to help Médecins Sans Frontières respond to the global pandemic. But at the same time, you realize the time savings benefits of doing everything within one place, in this case, the ArcGIS environment. I was particularly interested to see the workflow that you laid out, from the pre-processing, the sample collection, the classification, post-processing, and of course, map production. So great job. Our final lightning talk of the day, we come back to the US. We're going to Ohio, to Bowling Green State University, and Yu Chao.
This presentation is actually a class project. We have a class called the Introduction to Geospatial Science. In this class, the students never had the experience with the geospatial before. At the end of the semester, I required people to do a project. The project is about 3 weeks. The purpose of this project requirement is that I want to assess how students actually learned how to collect the geospatial data, how do they create the quality of the map. I also wanted them to understand the significance of the imagery and also enforce their ArcGIS Pro skills. Before this project, I asked each individual students to propose in what they wanted to do with the project. And then they submitted their proposal, and I could put them together, ask them to discuss and debating in the class. Eventually, whole class agreed that they will do a project with the glaciers in Glacier National Park. After they made the decision, and I tried to find some project available, people already done with that. Luckily, I find the NASA Earth Observatory website. I find that they actually did a similar project before, which is compare the glaciers in the 1984 and the year 2015. So I expect the students that can do the similar research after the project. The second step is to collect the Glacier National Park data. So students actually are required to individually to look at the different data, and then whole class put the data together. I wanted them to learn that not all data are the same. For example, in this case, some people collected a 64-meter DEM data. Some people picked up a 10-meter DEM data. So we discussed that, which one probably would be better for the project. Of course, 10-meter would be much better. Next step, they made the map for the Glacier National Park. They need to make the map for whole park, and they need to apply the skills they learned before this project. In this example, you can see that they used the DEM and also the hell shading to make the map. Some people also made the glacier map based upon the data they collect. On the left side, those are all the glaciers in the park. On the right side, you can see that there are some large glaciers. Specifically, they're concentrated in the middle of the park and northwest of the park. Some people also made the 3D maps, and this is a 3D map of the Blackfoot, which is the largest glacier in the Glacier National Park. Next step that did is that need to find the available Landsat images from USGS Earth Explorer website. So this is a list that find from that website. They checked all those the specific date, and eventually they find that a lot of the images actually are cloudy. So they find those 4 are actually best for this project. And of course, all the data are in the summer season because it's the best time to view the glaciers. Then they put the images into the ArcGIS Pro, and they clipped the satellite imagery into the park here. On the left side, that's 1986 imagery. On the right side, this is 2020 imagery here. And then they look at the different band combinations techniques in the ArcGIS Pro. So in the ArcGIS Pro now, they have already set band combinations. There are natural color, there are color infrared, and there are land use band combination. But the best two that think best for the project is a land-water interface and also the vegetation analysis. So they think that those two are best to study the glaciers here. Then they're concentrated in the specific glaciers at different years here. This is from the middle of the national park. The largest glaciers is called Blackfoot, and there are also some like Jackson, which is the 6th largest one. So they look at those area and then compare the images at the different years. So for example, you can see that this is 1986, 1993, 2006, and 2020. You can see that from 1986 to 1993, the size actually are reduced. And in 1993 to 2006, size also reduced. But from 2006 to 2020, you can see that size actually is increased. The second area that look at is northwest corner of the national park. And there are 2 big glaciers in the area. So this is the result. So you can see that very similar to the early one. And you can, this is rainbow glaciers. You can see that it reduced the size between 1986 and 1993. And it further reduced from 1993 to 2006. But again, in the 2020, the size actually is increased. From this project, students really learned the importance of the images in the geospatial analysis. For me, I learned that the ArcGIS Pro actually is very easy to do the basic image processing, and that I didn't expect that before here. This is my presentation. Thank you for your attention here.
Well, Yu, thank you so much for rounding off our lightning talks this morning. Great presentation on particularly interesting class project there. I like the way you took the students through that discovery process to understand the differences between different resolution DEM products, how they compare, why they're best to use one versus the other, and also the way you brought in the use of 2D, 3D maps. And obviously, we think about satellites and the ability to go back in time is only true in certain types of satellites because of the amount of time that they've been around. And Landsat obviously is a great one to look back into the 1980s to data that other satellites obviously can't do because they have only recently launched, as we've seen this space renaissance that I mentioned yesterday. So those conclude our talks. What I'd like to do is invite Maddie, Warren, and you to join me now. So if you could come on. And whilst they're setting up, we do have Q&A open. And if you have questions for any one or all three of them, please put those into the Q&A. I did see one that was entered earlier that I thought I would answer, which was talking about when are the presentations going to be available? This came up yesterday. The specific one I think that was requested today was the link to Warren's story map for his presentation. He has posted that link in, but Esri Events have responded with, typically we do 6 to 8 weeks, we publish all of the proceedings for this. And the reason it takes that long, because people were commenting yesterday, surely you can do it quicker. Think about the number of events that we have, the number of activities that are going on within Esri. We take time to make sure that we not only prepare the videos correctly, but we also prepare proceedings web pages and start to make the data and the videos and supporting information available to you. So that answers that one. So we'll keep an eye out on the questions. But Maddie, you and Warren, welcome. It's great to have you all on live here. I'd like to start off with, let's start off with some questions for Maddie and the trip that you made to the Falklands. I'm assuming that was a lot of fun, wasn't it?
I unfortunately did not get to go to the Falklands. A couple of our collaborators did the drone flights.
So you did all the hard work back at the office. Interesting. Yes. So if you look at that project, I'm curious to understand more how you integrated Esri technology into your project.
Yeah, so the training and the inference was done in Jupyter Notebook. So the fun part was visualizing the detections on the map by georeferencing back to the original orthomosaics and then converting those to shapefiles, of course. So this was done with a combination of ArcGIS API for Python and a couple different scientific Python libraries. So once those detections were exported as those shapefiles, I switched all the data over to ArcGIS Pro, where I could obviously fully visualize all the detections overlaid on all of those orthomosaics. And then within ArcGIS Pro, I was able to do kind of like a QA, QC on the detections, explore the data further, and then test out ideas for future geospatial analysis, and then eventually upload everything to ArcGIS Online to create a comprehensive web app.
Wonderful. Oh, that sounds great. And clarification point for me, you mentioned, I think it was like 40,000 training samples. Was that something that you would iteratively do, or did you have to go about clicking on 40,000 samples all in one go?
Yeah, so I think that we started with about 20,000 training samples, and I added probably around 5,000 more throughout each training iteration just to get the accuracy a bit higher. But that is something that I did all by hand by myself. And I think it took around 40 hours.
Wow, no, that is quite an effort, I must say. And then for you, what do you see as the key benefits of using ArcGIS for this wildlife population monitoring project that you did?
Yeah, so of course, this work itself is really exciting, and I think it's going to be really beneficial for seabird monitoring. And there have already been so many studies highlighting the benefits of using deep learning to detect and count wildlife in drone or satellite imagery. So I definitely don't need to sell you all on that idea. Instead, I think it's more important to highlight the benefit of these methods within the GIS world. So this particular project was one of the first studies to successfully use deep learning for seabird counts at such large colonies. And if we just did these counts on the individual images, we would still get accurate population estimates, but it would stop there. So by counting seabirds on the larger orthomosaics, we can not only get their individual locations, but it can be easily integrated within ArcGIS. And then from there, the possibilities are endless. By using ArcGIS, we can create a whole new research project just exploring how to translate individual bird counts to representative breeding pair estimates by analyzing the spacing between individuals and quantifying empty nests.
Excellent. And is the project continuing? Or?
I'm not sure at this point in time, but I hope so.
Good. No, that sounds good. I wish you good luck in taking that through over the years. Noticed your internet was jumping up and down a little bit there, a little hiccup, but it did come through clear. We'll move on to Warren. Thank you for your great presentation. Obviously, I liked your UK connection and Harry Potter and his molehills, and was wondering for you, what I saw was a real mix of products being used there to get the job done. Do you want to talk us through that?
Yeah. First of all, the Harry Potter connection is that it's a Hermione's field. And my colleague, he's an ecologist, he does some research there. So part of my teaching is support of the faculty. And normally what he introduce species counts using traditional methods of imagery and drawing grids and counting in Excel. So we started to look at use of the Esri product, but during that time, COVID hit, so then everyone went home. So then we were challenged with how can we continue this? So we decided to look at some online resources. Of course, we've got the story map, which I presented that in. Yeah. I have that as all of my courses. And then I gave them the data that my colleague collected to upload to the cloud to process it in a photogrammetry tool, which enabled them to then download the orthomosaic. And then to train it, again, the reason why we're doing this is because many of our students are, they're all remote, and they may not have the hardware that we may need, or the platform. So this option was working well. They uploaded the imagery, generated the orthomosaic, downloaded the ortho. And going through that whole process, we're sharing with them what is the value of GIS and these different tools, because they may not have even used GIS. And this is only a few modules in the class. It's a whole ecology class. So once you download the imagery, they're able to upload it then to another platform, which enables them to train the detector. It's called Pictera. And in doing so, you identify where the molehills are, where there are no molehills. And we all come up with a little different answer. And we explain what the process is and how we have different answers. Once they're able to do that, they download the data as a shapefile. And then, again, we're stuck with how can we perform analysis on here to see what the distribution pattern is and perform a density, what we normally do, use it with Pro. So we used a tool called PAST, and that is a small software you can download onto your desktop and run it either on a Mac or a Windows. And it was a great output to what we would normally do in the Esri product, or have them perform it in Excel. Yeah. And so it's a great exercise.
No, good. I know clearly when COVID hit last year, everybody had to make some quick choices and bring in whatever tools worked to continue working. And I know Esri did a lot of work behind the scenes to make sure that we supported the academic community. And it's an interesting one, isn't it? Because there's this platform challenge of, ArcGIS isn't on a Mac. I don't see it becoming available on a Mac. So it's either Windows or go to the cloud with SaaS offerings, and obviously utilize story maps and other capabilities. I think more and more the ability to switch to SaaS offerings is going to be really helpful, and that's what we continue to work on. So I'm hoping that will support the academic community through whatever comes up next. I mean, who knows when new normal becomes and what new normal is. So that's great. I'm glad you've been able to join us. I really enjoyed your presentation and the project that you set for your class. When you take a look at the satellite imagery, obviously you use Landsat. Did you consider other software, other data sources for the project?
Actually, this second time I teach this class,
Mhm.
and the last one was 2 years ago. And last time I taught that, I used ArcGIS for the GIS part, and then I used the Esri for the
Uh-huh.
image part, actually.
Right.
So that was 2 years ago. And this time, it's first time in our university we use ArcGIS Pro. So I'm not sure how that will work. So, but the result is really, really exciting, actually.
Excellent. And so you say it's the first time you've used Pro. Hopefully it's not the first time you've used ArcGIS though.
No, we use ArcGIS for a while, but
Uh-huh.
For the ArcGIS Pro, I actually pushed the university for 3 years and asked them migrate from the ArcGIS to ArcGIS Pro.
Uh-huh.
And I think I have a pretty good relationship with the university ITS, but it still took 3 years for me to to do that.
Wow.
Actually.
Right.
So this is the first semester in our university using the ArcGIS Pro.
Good. And it sounds like it went very successfully.
Yeah, it is. And it's a little bit difficult for me at the beginning because I used the tool with ArcGIS, but it's really kind of no problem with the students because that's the first time they use ArcGIS software.
Yes.
So they really don't need to migrate for them. So the only person need to migrate is me, actually. So it took a while, but I'm really glad I did.
Good. Yeah, I know it's like anything, isn't it? When you go away from something that you're very familiar with onto something new, at the end of the day, you just got to rip off that Band-Aid and go for it. And my experience has been similar that, you make that move and think about the amount of research and development that Esri has done into ArcGIS Pro and supporting products to really enable the teaching of remote sensing within ArcGIS. So I'm glad you're able to persuade the IT organization to take care of that for you finally. We've got some questions coming in online. Let's have a look and see. I think there was definitely one for Maddie. Have you or anyone used this on cliff-dwelling seabirds?
So I have not personally, but that would be one of our next steps if we can continue this project. So in this particular island, there are a couple birds that nest below the cliffs. So that kind of obviously introduces issues with drone flights and trying to get overhead images. And then, of course, detecting those birds, especially there's a lot of issues with shadows and stuff like that. So not personally, but that would hopefully be one of our next steps.
Yeah, absolutely. And then a nice question from a good long-term friend of ours, Ann Johnson. She says, many presenters have said, and then I saved out to shapefile. She's asking why shapefile rather than feature class? So for all three of you or anyone who wants to answer that one.
And for me, when I download, it gives you the option of either a CSV or a shapefile. It does not give you the download option as a geodatabase, but that would be easily imported into the geodatabase.
In Pro, it's easy to output or create a feature class to then share within either your Pro organization or ArcGIS Online. Maddie, you have any thoughts on that? Oh, you.
Yeah, sorry. No. So for me, when students search for the data on the internet, and most of the data actually are shape files. But after they actually collect the data, and I ask them to convert that into the geodatabase. So that's my situation.
Great, excellent. One of the things I wanted to also talk to you all about was yesterday we did a couple of surveys of the audience. One of them was to look at drone processing software, because drones clearly are being used more and more. We talk about it democratizing remote sensing. It was really interesting to see of the softwares that were used, the majority were desktop products like Drone to Map. I think over 26% were using that. Pix4D, 33%. And then Agisoft, 22%. They were the main desktop ones. There were others that we didn't have on the list that people selected. So we know that there's a wide range. But I'm curious, as you see drone usage becoming more prevalent in your work, how important is it for you to have that workflow integrated into ArcGIS?
For me, when I work with my administration, they had originally said, we just download the data. Well, the whole workflow that I have with my industry students, they need to know the actual workflow, what's involved, the licensing, how to set up the flight plan, do the ground control points, the whole processing. And so, and they need to have it then and now. So I think it's very important that we share with them how to collect that data. Now, there'll be different levels of accuracy depending if you're a surveyor or if you're mapping birds. But I think it's very important.
Yeah, and we haven't really spent much time up until this event talking about site scan for ArcGIS for the academic community, because to be honest with you, we didn't have a pricing structure that would make sense for the academic community, but we do have that now. And that whole process of teaching students how to do the flight planning, giving them a range of different flight planning options, bringing in FAA data, bringing in ArcGIS features into the software to plan your flight, having that data collected using the autonomous flight planning software, and then delivering it into either Enterprise or ArcGIS Online is a really smooth end-to-end workflow. So we really hope that we get the opportunity to start working with the academic community and getting them more familiar with SiteScan for ArcGIS this coming year. Maddie, did you have any thoughts around the integration piece?
Yeah, so on my end, I mean, if I could go back and change anything, I would have just done all of this within the ArcGIS API. So I kind of was using just Jupyter Notebook on its own, and then I had Pix4D over here. And then I know that when they were doing the flights, they were using, I believe, Drone Deploy. So just a lot of things happening all over the place. And it definitely took longer than it should have.
Yeah.
So I think moving forward, it's going to be really important to just kind of have one centralized workflow.
Excellent. Great. One final quick question. Oh, actually, no, it's gone off the screen. So it is 10:45. I wanted to thank all three of you. Thank you, Maddie. Thank you, Warren. Thank you, but also thank Melanie and Dirk, who also presented at our lightning talks this morning. We now take a 5-minute break. And during that break, we actually will play a SiteScan video that was from last year's user conference. So please stay around, but take a quick break, and we'll resume in 5 minutes. Thanks, everyone.
Hi everyone, my name is Madeline Shorin, and I'm a solution engineer at Esri's Geo Experience Center. Today, we're at the San Bernardino International Airport in Southern California, where I'm excited to share a story of how GIS can be applied in a pretty unique way. A few months ago, the airport began construction on a new air cargo facility, which will help support the area's growing population. It's critical to keep stakeholders at the airport informed on construction progress in near real time. We can use a drone to do this using SiteScan for ArcGIS. When construction started, myself and several other colleagues came out to the airport to fly a drone over the construction area. We were excited. Driving out to the construction site, there was a ton of activity at the airport. And one of my favorite parts was seeing the sheriff's helicopter, which is actually housed at the airport, take off to respond to a call. And once we got out to the construction site, we got ready to fly the drone. We had 3 simple pieces of equipment with us: we had the drone's controller, and an iPad with SiteScan for ArcGIS. Before the drone can take off, the first step was to develop the flight plan on the SiteScan app. SiteScan makes it easy to develop these plans on the fly. Here, I select the flight plans widget and choose area survey. SiteScan for ArcGIS automatically connects to ArcGIS Online, accessing web maps and layers for reference. Bringing in the construction perimeter, we'll now start crafting the plan. Very simply, we drag the vertices of the plan over the area of interest. The flight path is automatically generated, and the taskbar at the bottom of the screen dynamically updates. Here we can see if we fly at 200 feet, how long the flight will take, the flight's pixel resolution, and an estimated amount of batteries. SiteScan also allows the pilot to interactively explore different flight options. For example, setting the flight altitude to 400 feet, the flight time is cut in half, pixel resolution remains high, and the battery needs are dramatically reduced. But because we're at an airport, we have to fly significantly lower, so we'll stick to 200 feet. With the flight plan all ready to go, the drone goes through its pre-flight checklist and then takes off. It follows the flight path and captures images over the area specified. It was really exciting to watch the drone take off for the first time and come in for its landing. From here, the next step was to process the imagery in the cloud. Opening the SiteScan Manager in a browser, we simply added the collected images to an existing project at the airport. To begin processing, we simply drag and drop photos from the drone's SD card into the uploader. The images are processed automatically and can be shared directly to my ArcGIS Online organization, harnessing the power of the cloud. Let's take a look at process results that were captured in our first drone flight at the airport. Turning on the orthomosaic and zooming in just west of the construction site, we can see the San Bernardino Emergency Training Center. This is where trainees are exposed to live fire conditions across various aircraft types. We can even see fire hoses laid out and ready for an exercise with this plane and helicopter, which we actually saw happening in real time during our trip to the airport. Flying over to our construction site, we can see activity that was removing an unneeded part of the taxiway. SiteScan also produced 3D information, including a digital terrain model and digital surface model. Bringing this data into a web scene, we can use measurement tools to analyze it. And flying back down to our construction site, we'll use a before and after digital terrain model to measure volume change over the most recent construction area. Dropping in just a few points, construction progress is calculated. About 24,000 cubic meters have been graded. And there you go. Our drone workflow for the day is all done, all hosted completely in the cloud. SiteScan for ArcGIS made it easy to track construction progress using a drone, and we had a ton of fun visiting the airport. Thanks for watching.
All right, so welcome back, everybody. So what we're going to cover in this next session is how the Academy works with Esri. And what do we mean by that? As we mentioned earlier, by Academy, we simply mean the academic community. And very often we get questions such as, how do I get access to technology on campus? Or what exactly is provided as part of Esri's education program offerings? Or who do I go to get further support? Or what are some of the resources that are out there to help me as an educator? So we'll cover a number of these different items, but first I'd like to introduce Delphine Cana from our Learn ArcGIS team. So Delphine, would you like to introduce yourself?
Tips. Hi everyone, I am Delphine Cana. I am on the Learn ArcGIS team at Esri, and I focus particularly on producing learning materials for imagery and remote sensing.
Wonderful, thank you. So let's talk a little bit about just education within Esri at first. Of course, there's our education team and lots of the wonderful folks that many of you know that you see there on the screen. A lot of us that our job is really to support the academic community, and some of us focus on K-12, some of us focus on higher education, some on research institutes, some cover a little bit of all. But again, the main role and goal and focus is to support you. Now, also, in addition, there's lots and lots and lots of other teams at Esri that work very closely with the academic community in terms of providing educational content, in terms of providing support. And you see some of these teams listed on the slide. So as Delphine is going to talk a little bit about our wonderful LearnRGS team that has produced so many resources recently to help support educators. Also educational services that are familiar Esri training options that are available that we mentioned earlier. And lots of other folks across product management, product development, and such that, again, work closely with some of our academic colleagues to either provide support and advice or take advice from the academic community as we're developing our RGS as a platform, as a technology. And of course, wonderful customer service, technical support, lots of people. But also something else that's very important is we have so many Esri offices globally, and a lot of our audience today do come from outside of the US. So if you do fall in that category, do please work with your local Esri office, with local distributor, because they're there to support you as educators as well. All right, so how do we get access to licenses to technology, to these education programs that we have? And majority of the institutions out there have what we used to call the site license. We refer to it now as the Education Institution Agreement. And there's also a couple of other program offerings at the little smaller departmental licenses. But the goal of it is, of course, they all empower remote learning and just learning in general. And they all enable many different disciplines, many different domains. And what we're seeing on the right-hand side is by far my old favorite dashboard. This University of Michigan, our colleagues have developed it there. And what's really impressive is not only that close to 7,000 users have logged in, have used technology and continue to do so, but just the pie charts that are there, the diversity of programs and degrees that are leveraging this fascinating technology. It's just inspiring. So anyway, so for teaching and research, we provide pretty much unlimited technology, limited named users, and so on. So we want to enable everyone on campus to get access to it. Now, in terms of the access piece, the one thing, what you see on the slide there, there's this enable single sign-on option, or what is listed there. And it's probably one of the most important things that we need to think about in terms of providing access to ArcGIS. That is, we want to get away from the manual account creation in ArcGIS Online, manual assignment of licenses, and a lot of the manual sort of administration work that sometimes does take place. We want to integrate with existing campus systems and to leverage whatever the identity provider is on campus so that students, faculty, staff can log in with their own university IDs. So it's a technology that's deployed for everyone at the institution. It needs to be managed as such. And those couple of suggestions there are what we recommend as a best practice in terms of getting access. So that is one thing that if you don't have yet at your institution, we highly recommend that you start having some of those conversations with your IT colleagues, with other colleagues across campus that either do GIS support or do GIS in general, and so on. All right, so another common question that we get, well, what is included in these education program offerings? So of course, access to ArcGIS Online, all apps, ArcGIS Pro, and Nigel and our colleagues in the session earlier mentioned that a lot of things have moved and have shifted to the cloud, and there's so many capabilities that are available there just as part of cloud offerings. So all of that is provided. Image analysts, server analysts, the things that are image server that are a little more specific to the imagery remote sensing educator community. There are a couple of things that are available as additional costs, so drone to map and site scan as well, but they're much reduced compared to commercial pricing. There are special education offerings that are available as well. And then we also mentioned ArcGIS Image for ArcGIS Online that is right now in beta, and so we hopefully look forward to including that as part of the just the overall education programs. All right, so where do I go for help? And of course, it depends on many things, but typically, and usually it always, I should say, there is a person a license coordinator, we often refer to them, that sort of kind of manages, or at least is the point contact for any sort of access or in terms of managing the actual licenses across the institution. Of course, the support models for GIS vary greatly among the different institutions. They can sit in different offices. They could be in IT, they could be in, in the GIS support office, they can be in library, they could be in many in the academic department and so on. But the point of it is that there's someone that is on campus that is kind of the point contact for anything ArcGIS. So do work closely with them. And again, just to mention single sign-on, it's not on this individual solely to make it happen, but again, to liaise with partners, IT colleagues across campus to ensure again that ArcGIS is deployed just across all the institution. It is available for everyone at the institution. Also, so obviously say you're teaching, you don't know where to go to support, you're kind of starting with ArcGIS. That license coordinator could be a good person to start with on campus. In the US, so all the institutions, there's an account manager there that is available to provide individual support or to liaise with Esri to help answer any questions that you might have. And again, for a global audience, there are local Esri offices in many different countries that are there to also support the academic community. And if you don't know where to go to, always come to us, the education teams. You see the email there, so send us a note. I don't know who to contact on campus, or I have this idea, but I don't know what to do. So feel free to reach out to us. And of course, again, as I mentioned earlier, and to reiterate again, there is this all of Esri that is there. They're standing behind to support the community. There is the former GeoNet, which is now the Esri community that we mentioned earlier. There's lots of folks that are on there from obviously all of us, educators, folks that support education, and folks across various teams within Esri. So we're here to support you. So with that, I'm going to shift it over to Delphine to cover in a little bit more detail one of the wonderful resources that we mentioned earlier that was created, particularly with the educator in mind, the folks that are working in this imagery and remote sensing field. So Delphine?
Yes, thanks, Jerry. Here we are. Okay. So yes, as mentioned, I am on the Learn ArcGIS team, and my team recently developed a learning package called Introduction to Imagery and Remote Sensing. It contains teaching materials to aid the development of university-level curricula on the subject of imagery and remote sensing. We created this approach, we created this package because technology changes very rapidly, as we know. There are constantly new tools and new workflows coming up. And we know it is hard for you as educators to keep up. So we wanted to save instructors time by providing ready-made learning materials that can be used in the classroom or as assignments. We also wanted to choose materials to demonstrate modern workflows and current best practices. To develop this project, we worked collaboratively with our colleagues from Esri's imagery team, as well as several other experts. The result is a learning package which offers a growing body of materials. It is free to use for all audiences. It is organized by themes so that you can pick and choose items of relevance to your course. The materials are introductory level and cover the basics of imagery and remote sensing. But we also wanted to give a taste of engaging techniques such as working with drone imagery, LiDAR point clouds, and deep learning. There are 3 types of learning materials in the package: interactive web apps, hands-on labs, and overview slides. The interactive web apps are meant to, as short activities to illustrate a fundamental remote sensing concept, such as spatial resolution or visualizing change. You can use them in the classroom to demonstrate a concept, or you can assign them as short homeworks. Hands-on labs are in-depth exercises that enable students to experience technology that enables students to experience end-to-end workflows while gaining an understanding of how imagery and GIS technology can solve real-world problems. The workflows demonstrate step by step. They take from 30 to 90 minutes to complete. And in terms of software, they rely on ArcGIS Pro, ArcGIS Online, Drone to Map for the lessons based on drone imagery, and some web apps for the most introductory materials. Each lab is offered in PDF format. The hands-on labs are based on engaging scenarios, such as measuring a shrinking lake in China, tracking development on the Suez Canal over time, exploring a volcanic eruption in Hawaii, or assessing hail damage in cornfields. We demonstrate a number of techniques, such as choosing band combinations and spectral indices, unsupervised and supervised classification, working with time series data, and more. So to summarize, we currently have 7 web apps, 5 hands-on labs, and 5 overview slide decks. Looking ahead, we are updating all materials regularly to match software releases and current best practices. We will progressively add more materials, and we would love to work more collaboratively with you, the members of the academic community. So we look forward to getting your feedback, and please don't hesitate to reach out with new lab ideas and other suggestions. Back to you, Jerry.
All right, wonderful, Delphine. Yeah, just phenomenal work there on this particular package, as well as just all the wonderful resources and time and efforts by all the LearnArcGIS team members to create some of the content that is available. And as Delphine mentioned, the academic community is welcome if you're interested in contributing with a lesson or have ideas or suggestions. So the team is very, very much receptive to that. All right, so with that, let's go ahead and proceed with our next session. So again, as we go, do feel free to keep questions coming in the Q&A, and we'll be happy to answer them. There are a few folks that they're here just for that purpose, to help answer your questions. So in this next session, we'll take a look at what's new with Esri imagery and remote sensing. And just as educators, there's so many things that are happening that we're involved with, they're working on. And as we have expressed yesterday and sort of all along, it's very difficult to keep up of what is happening, what are the new things happening, new capabilities that are out there. So we'll take a little bit of time, and Peter Becker is going to share with us what is new with Esri imagery story. So with that said, let Peter take it from there.
Thanks, Jerry. Let me get started with what's new with Esri imagery and remote sensing. As you've realized, ArcGIS is a comprehensive imagery system. It's perfect for research, but also teaching students to be fully prepared for the workplace and driving them to be the future leaders in this field. ArcGIS has a lot of capabilities, and in imagery, we break those down into 5 key areas: content, where does the imagery come from; management, how to manage that data and make it accessible; imagery mapping, which is turning that imagery into various products like orthophotos; analysis, which is the extraction of information from that imagery; and then visualization and exploitation, to make that imagery integrate with various applications for human use. The imagery capabilities of ArcGIS are enabled through a suite of products that we refer to as ArcGIS Image. And this provides 4 different deployments, either in desktop, utilizing ArcGIS Pro and extending it with ArcGIS Image Analyst for ArcGIS Pro; in ArcGIS Enterprise, by extending that with ArcGIS Image Server for ArcGIS Enterprise; within ArcGIS Online, by extending it using ArcGIS Image for ArcGIS Online; and then also as ArcGIS Image Dedicated, which I'll explain later, provides compute to organizations. So let me start with ArcGIS Pro, which is a premium desktop GIS that includes extensive image management, processing, and visualization capabilities. Within ArcGIS Pro, you can load in all types of imagery, provide access web services, use what we call raster types to bring in imagery with their metadata, create mosaic data sets that I'll be coming to in a minute, but also work with things like multidimensional data, have access to hundreds of raster functions, perform auto-rectification, georeferencing. There are a lot of capabilities directly within ArcGIS Pro. This then gets extended with ArcGIS Image Analyst for ArcGIS Pro. And this provides much more advanced functionality, advanced raster functions. It provides advanced multi-dimensional analysis capabilities, but also tools like image classification, change detection, deep learning, working with perspective imagery, motion imagery, stereo, as well as a pixel editor for editing potentially very, very large rasters. Next, ArcGIS Image Server for ArcGIS Enterprise provides 5 sub-capabilities. One is image hosting, which enables users to upload imagery to the server and have that served back. That imagery can be served back as tiled imagery, which streams the images back to the client applications, which then render it. And those client applications could be ArcGIS Pro or could be various web applications. Dynamic imagery, which is where clients make requests to the server then processes the data and returns literally instantaneously those results back to the client application. Image analysis, which is for large analytic jobs, enabling you to submit jobs to the server, which then gets processed and distributed processing and storage, creating very large data sets, which are then made accessible. And then author mapping, which is really that image mapping capability to create products such as orthophotos and terrain models and do things like aero triangulation on the server. This all works in an on-premise, but also can be easily extended to work in the cloud infrastructures such as Amazon and Azure. We're about to release ArcGIS Image for ArcGIS Online, which takes those capabilities of the enterprise and makes those available in an online pure SaaS form. And again, with that, you have the ability to host imagery, in other words, upload your imagery to ArcGIS Online, have that streamed from online as tiled imagery. It's not just cache, but really pixel values coming back to the client applications, enabling the dynamic imagery where the server is processing the data to return the results, and then also the image analysis capabilities. What we're also releasing is ArcGIS Image Dedicated. And this is realizing that there are organizations that have large volumes of imagery that they cannot upload into ArcGIS Online, but also do not want to stand up their own infrastructure for ArcGIS Enterprise. So ArcGIS Image Dedicated enables users to define storage location anywhere in the world, as long as it's in Amazon or Azure. And then Esri will stand up infrastructure next to that storage that will provide those capabilities of streaming tiled imagery, dynamic imagery, and also performing any type of processing and analysis against those large collections of data. Let me move on to content. Content is something that we support immensely. So we support lots of different formats. I mean, literally over 150 formats are supported by ArcGIS with their different raster types, which means that we support not only the pixels, but also the meta information that comes with those data. We support data from different platforms, that's satellite, aerial, drone, and terrestrial data. We support a wide range of modalities. This is categorical data, multispectral data, LiDAR, radar, video. These are lots of different modalities. And then we also support the access to that data from services. These could be services such as OGC, WMS, and WCS, but more and more, these are services which are streamed from ArcGIS Image Server, and those include all types of imagery, but also services that Esri provides, such as in the Living Atlas, we provide access to all the Sentinel-2 data or the Landsat 8 data, and these are not just pretty pictures, but data sets that you can actually get access to all the temporal data and the multispectral data and have the services process and return that data. It also includes elevation data for the whole world, There are massive amounts of data sets which are available within the Living Atlas, and certainly I suggest you get your students to investigate that and see all the different data sets and what they can do with them all. Let's move on to image management. Image management is fundamental. It's the key capability of getting that imagery and making it accessible to users and then serving it out to a broader community. The aims of this really are to take that content that could be your user content, it could be partner content, it could be content from public data sets such as Landsat and Sentinel, or content from the Living Atlas, and make that accessible in the various applications. And within ArcGIS, that is done through web maps. As you probably see, you first create a web map and then you create an application from a web map. And a web map really is a set of layers which can be wide-ranging. They can be things like tile cache as base maps. They can be tiled imagery, streaming those pixels, dynamic imagery with a server performing the processing, but also other types of data, point clouds, meshes, processing and analysis. And what we want to do is to make those accessible to those applications. And the fundamental way that this is done is through the Mosaic dataset. The Mosaic dataset really is the optimal model for image and raster management. It allows us to reference imagery from all different sources and define how not only reference to the data, but also defines the meta information that extracted from that data, and then defines how to process and transform that imagery into various products. And what we've done recently is to extend that to what we call a multi-dimensional Mosaic dataset. That's taking that concept and extending it to support additional dimensions and variables. And that allows us to take not just a single NetCDF, but collections of NetCDF or other multi-dimensional data sets, and combine them potentially with other data sets such as Landsat and other temporal or multi-dimensional data into a single multi-dimensional Mosaic data set. And that provides a very powerful way of looking through large collections of data. That has a lot of advantages, but sometimes there's a requirement to transform that into a pixel-aligned data cube. And we call one of those we call that CRF. CRF is a really optimized structure for storing pixel-aligned data, which could be multidimensional, specifically in cloud storage. And we refer to that as a multidimensional CRF. And then what we also added recently was the ability to transpose that. And the key capability of that is to really enable fast temporal access to that data. So for management of data in ArcGIS, we've always had the ability to use ArcGIS Pro and manage that data. That data could be local data, it could be data sitting in the cloud, and that's done using Mosaic data sets. Very often, once you have your Mosaic data set and you're happy with the results, what you may want to do is to convert that into tile cache and upload that into ArcGIS Online. And that then makes that accessible, simple base maps for use in web and desktop applications. We've also had the ability to take that Mosaic data set and publish it to Image Server, and that would allow us to access that as dynamic imagery, enabling users to access the imagery, pan and zoom around with the server processing that data. And as I explained, we've added hosted imagery, tiled imagery, image analysis, and author mapping to ArcGIS Image Server, really extending the capabilities of how it works within an enterprise. And that hosted imagery capability is something we sometimes refer to as user managed versus curator managed. So curator managed was more the capability that somebody within an organization collects together all the imagery for the organization and publishes that. Whilst the user managed is much more the individual users going, oh, I've got some data on my desktop, I need to push it or upload it into ArcGIS Enterprise, and then I can share that with larger numbers of users for them to do additional analysis or view that data. And that we've extended with ArcGIS Online. So we're now releasing ArcGIS Image for ArcGIS Online, which takes that capability and makes that available without you needing to actually set up ArcGIS Enterprise. And as I mentioned previously, it's also for organizations that have large collections of imagery and do not want to upload that data into ArcGIS Online, or want to, for example, utilize large collections of public data. What they can do is get ArcGIS Image dedicated. In that case, Esri literally stand up on-demand servers next to that storage and enable you to control those to perform the processing or stream that data back to the applications. So those are really all new capabilities that are added, which will really extend the ability for large numbers of users to make use of the real power within ArcGIS for managing the data. Let me move on to image mapping, which is the ability to take imagery from sensors, be they aerial, satellite, and drones, and transform that data into products such as orthophotos and terrain models. We provide a range of products to do that. SiteScan is the ability as a full SaaS to take drone imagery, not only to plan those drone flights, but also to take that imagery, upload it into the cloud, and transform it into both 2D and 3D products, such as 3D meshes and point clouds. There's Drone to Map, which is a standalone desktop solution for taking drone imagery and processing it. And we have Author Mapping, which is really extending ArcGIS Pro to perform not only the processing of drone imagery, but also to perform satellite imagery, aerial imagery, and a lot of people are now using that specifically for the historical scanned imagery. And then Author Maker is really extending the capabilities of ArcGIS Image Server to provide a web interface to enable processing of drone imagery from ArcGIS Enterprise. And then recently, we've added ArcGIS Shore. So you've seen some discussions about ArcGIS Shore and its capability of really taking imagery and transforming it into exquisite three-dimensional 3D meshes, as well as true orthophotos at scale. Let's move on to image analysis. Image analysis is really the extraction of information from imagery. And you see we have a plethora of different capabilities, really extending the pedigree that Esri has had for many years in spatial analysis, and which is not working only with sort of imagery, but also working with raster data sets, such as terrain models and things like that. So the image analysis capabilities are extensive. They support not only more traditional things like image classification, but pixel classification, object classification, detection. So a lot of different capabilities. And I'll go into a couple of the new things that are happening in this area. Deep learning is an exciting field that many students and researchers really want to start using. And within ArcGIS, we have integrated different frameworks. That includes TensorFlow, Scikit-learn, PyTorch. These are all frameworks which are now accessible within ArcGIS. This allows you to work with different data types. So not only do we work with RGB data, but we allow these frameworks to work with point clouds, text, oriented imagery, motion imagery, LiDAR, and then perform ranges of tasks such as pixel classification, image classification, object detection, performing super resolution. So these are all tasks which are available within ArcGIS, and we've extended in various ways. Recently we've added faster RCNN, and that provides better object detection, as well as YOLO, which provides a library of objects that can be easily identified, but then also used as training to extend those object identification. We support multispectral imagery as well as sparse training, and these are very important for working with, for example, Landsat data and Sentinel data, as well as multi-label classification. So let's have a look at some of the different tasks that you can use within ArcGIS in deep learning. One of them is object classification for things like identifying damaged or undamaged buildings. Object detection, which allows us to really extract the location of objects out of the imagery. That imagery could be orthophotos, but it could also be video or oriented imagery. There is pixel classification. So this is really doing things like classification of things like land cover. Then there's instance segmentation. So this is doing things like the extraction of buildings, cars. Road extraction, which is really focusing on the extraction of linear features. Then there's edge detection, which is very interesting, especially for agricultural applications, where the system is really trying to identify the boundaries between areas. Then there's a range of change detection tools. So how do we actually use deep learning for change detection? And then a number of additional interesting aspects, which are things like super resolution, to increase the resolution of imagery, or to fuse optical imagery with radar imagery. So these are all different tasks that can be performed within ArcGIS. And the deep learning workflows are not just single components, they really fit together as a complete workflow. So I'd mentioned before the image management capabilities of the system to manage all the data, but then within ArcGIS, we provide the tools to do the labeling, which sometimes requires a lot of manual work to extract a lot of representative samples of the data. The preparation of that data, in other words, cutting it into the sort of chips that are used as input to the training models, then actually doing the training models or getting the training models to learn. Once we have those models, then the actual inferencing to extract that information from potentially massive volumes of imagery. And then once that information has been extracted, really perform the analysis on that, very often moving in to use various other types of spatial analysis to determine the relationship between those different objects which are extracted, and then taking that information and further putting it into the application that makes use of it, which very often is a field application or some form of a monitoring application. So we really cover the full workflow end to end. Another new thing that we've recently released are actually pre-trained models. We realize that training deep learning can be an extremely arduous and expensive process to get those models trained up, because it requires potentially massive amounts of sample data. So what we've done is collected that sample data, performed the learning tasks, and then provide those pre-trained models available to users to literally download and utilize them for inferencing, or download them and use them as the basis for further training. So this really simplifies the process of applying deep learning to various applications. And you can download these deep learning packages from the Living Atlas. So you go to the Living Atlas, search for deep learning, you will find these packages, deep learning packages, and you can now download those and use those within not only the desktop applications, but also enterprise applications, as well as in ArcGIS Online. Another area is change detection. We've done a lot of recent work in improving the tools available for change detection. And these can be split into two groups. There is image-to-image change, which is really taking two images and trying to identify what is the difference between those. And then the time series analysis, where we're taking collections of images and looking through them, looking at time and seeing how things have changed in time. And that includes things like CCDC, as well as Landtrender. The change detection tools are new tools added to ArcGIS Pro, which provide guided workflows for taking one or more images and determining either categorical change or time series change or just pixel changes. Then there's Landtrender, looking at the different trends to identify when a forest was cut, monitor how it developed over time, not on a single pixel, but over a very large area. And that fits very well into the multidimensional raster analysis capabilities within ArcGIS, which are also extensive. And they allow us to take multidimensional data sets and aggregate them, perform trend analysis, predictive analysis, do things like anomaly detection. And that enables, and what we enable really, are the tools such as harmonic regression, to really take those data sets, look through time, and find trends. What is the trend in the data, and when does that trend break? So that allows a lot of very, very powerful analysis to be done. These analysis capabilities are not only available in the desktop, they're also available in the enterprise, and we're now adding those also to ArcGIS Online. ArcGIS Image for ArcGIS Online extends ArcGIS Online with these raster analysis capabilities. It includes over 26 ready-to-use tools that you can just select, define the inputs, and run. It also includes a raster function editor that allows you to take over 150 different raster functions and chain them together to perform all different types of processing and analysis, and then apply those, and the service will go process that data and return those results to you. So those outputs can either be tiled imagery or dynamic imagery, or they could actually be feature services. You may be running a deep learning tool and it's supposed to extract, for example, features. Another area is Python. These extensive capabilities are available through two APIs. One is the ArcGIS API for Python, allows users to manage the imagery and raster data and perform a whole load of tasks within ArcGIS. And then there is ArcPy, which really is the powerful and comprehensive library that provides access to the whole range of imagery analysis and raster analysis tools that are available. So ArcGIS API for Python is the sort of the lighter weight set of tools. These can be directly accessed within notebooks. There could be an ArcGIS notebook, a Juniper notebook. It can also be accessed within ArcGIS Pro. Similar, ArcPy has been extended recently. All these tools are available simply through Python and integrated into notebooks. The last area I want to talk about is visualization exploitation. And this is about taking the imagery and the vector data that are created and making those accessible and usable to humans in various forms. So enable, for example, stereo display of the imagery, working with oblique imagery, working with motion imagery, multidimensional data I've mentioned before, but then also taking those tools and making them accessible in mobile applications or web applications. You've seen there's a lot about story maps and how do we, for example, take imagery and incorporate the imagery and vector data into compelling story maps. And then there's a whole aspect of the web application development, the different application development frameworks, things like Web App Builder, and now coming up is Experience Builder. And these allow us to create either no-code or low-code applications. So you can really create any type of application that integrates imagery, not just as a backdrop, but really exploiting the content of that imagery, getting access to those pixel values, and using that in various applications. One of the new things that was added that may be of interest to a lot of students is the new instant apps within ArcGIS Online. And one of those instance apps is the imagery viewer. And that allows users to really just create a web map that is accessing the different imagery and vector data, and then literally by clicking on a couple of buttons, create an intuitive, simple to use imagery viewer application. Another area which is new and being extended significantly is oriented imagery. What oriented imagery really does is extend ArcGIS to work with all the other types of imagery that are available. Things like for inspection imagery, street view imagery, oblique imagery, video imagery that may be recorded from a drone. If you specify a point on the ground, it'll identify the best imagery for that area, display that imagery in conjunction with the vector data there, as well as now be able to superimpose that imagery into the vectors. So if there's appropriate orientation with the imagery, you can actually superimpose it into, for example, point clouds and fuse it into the 3D scenes. So definitely have a look into that area as well. So all this is accessible through ArcGIS. There's also a specific website, ArcGIS Imagery Workflows, and that really provides the best practices. It's continuously updated with the best practices for how to perform all these different tasks within ArcGIS. It really covers not only the content, the various best practices for image management, mapping, analysis, and visualization. So all these are continuously updated, continuously new, so do have a look at those. For that, I covered all the different aspects of ArcGIS. Hopefully you'll realize that it's a really comprehensive system with a lot of capabilities, and there's continuously new functionality being added all the time. So with that, I'll hand you back, and thank you very much. Bye.
All right, so wonderful job by Peter Becker sharing all of our imagery capabilities. Indeed, lots of different options there. So what we're going to do is take a short break, and when we get back, we're going to proceed with our results from the working group sessions that we covered yesterday. So let's take a break, and if you feel like listening, during the break there's going to be a short video that covers ArcGIS Image for ArcGIS Online. So you're welcome to take a listen to that. See you in a little bit.
Hosting imagery and image analysis are critical to the work of many organizations. ArcGIS Image for ArcGIS Online provides hosted imagery capabilities in addition to advanced raster analytics and visualization in the cloud. Last year, approximately 10,000 fires burnt 4.3 million acres of land in California. Now, to better understand burn severity and impacts of burn severity, I'm going to perform an analysis over the area of Santa Rosa. To do this analysis, I'm going to use a collection of 10 satellite scenes. And these scenes, they currently reside on my local machine. Now, let me show you how easy it is to host these images online. First, you can create your imagery layer. This could be a static tiled imagery layer, or it could be a dynamic imagery layer. This supports dynamic mosaicing and server-side on-the-fly processing. You specify a layer configuration, specify your raster type. In this case, it would be Sentinel-2. You can provide additional processing templates and parameters. And then all you got to do is drag in your images and relevant metadata, provide a title, tags, and you can create your imagery layer. This is now going to be a hosted imagery layer. Now, in the interest of time, I pre-created my imagery layer, which can be used directly for analysis. So here's our Sentinel service. And this is our region of interest. Now, we can continue our analysis by applying a raster function. We can fire up the raster function editor. The raster function editor gives you access to more than 150 different raster functions. These can be chained together to create custom workflows like this one, which is used to evaluate burn severity. Now you can tweak your parameters and run your analysis. I've pre-processed approximately 3,000 square miles worth of data. Everything in orange depicts high burn severity regions. Next, I also want to find out the number of buildings that are within the path of the fires. Given that I don't have pre-mapped building footprints, I could use the new deep learning tools within ArcGIS Online to extract my building footprints. For this, I use high-resolution imagery that's provided by Airbus. And I can pick from a library of deep learning models that are provided to me directly through the Living Atlas. We provide you with models to perform tree-point classification, land cover classification, road extraction, and more specifically, in this case, building footprint extraction. Let's look at the results. The model has extracted more than 25,000 building footprints, out of which it's been determined about 1,500 buildings are found to be in the path of the fire. So that was just one example where we show you how you can host large collections of imagery and dynamically mosaic and perform large-scale raster analytics using ArcGIS Image. Next, we're excited to see the kinds of problems that you can tackle using these new capabilities. With that, I'll hand it over to Hong Su, who's going to be talking a little bit about our new change detection capabilities that we've introduced in ArcGIS.
All right, so let's proceed with results from working group session. So if you recall, yesterday we had 3 wonderful working groups, 3 panel sessions on drones, on 3D imagery, and GeoAI. So those were the general headings that we discussed. So what we're going to do in this session is come back. We'll have a short synopsis of the results of those working groups, and then we'll take it further and we'll discuss a number of other items that came up, along with some of the resources that could help us as educators in each of those areas. And the moderator for this session is going to be Kansarina Cornier, solution engineer on the education team and a friend. Rina?
Thank you, Jerry. Thank you, Jerry. Hello, everyone. Yesterday, we had such a great discussion in each working group. Lots of sharing experience, knowledge, ideas, challenges, and of course, opportunities as well. We also talk about the trends in technologies. So very exciting sessions. We want to thank you all the panelists. And also we got a lot of questions. Thank you for all of you that participating. So what we are going to do in this session is we will present the result or the summary result of each working group and led by our academic leads. So I would like to welcome back Dr. Margaret Madden, Dr. Tommy Jordan, and also Dr. Charlotte O'Neill-Dunn. Thank you so much for being the academic leads for the working group and also present the result. Without further ado, let's start for the first working group topic, drones in education, challenges implementing IRSES technology. And with that, I would like to invite Charlotte O'Neill-Dunn.
Great. Well, one of the things we clearly heard yesterday is that people wanted to see more farm animals in this conference. And so I'm really happy to introduce everyone to Thumbelina here. It's hard to top Joseph in his beautiful musical renditions yesterday, but I'm going to try with the presence of Thumbelina. So Joseph, this is me throwing down my card. Well, great. Well, thanks everyone. And I'm going to go ahead and share my screen here and quickly talk through the lessons and concerns that we heard from yesterday's session. So how are we looking there? Hopefully seeing the screen. And so one of the things that was clear is that people are really struggling to get support for their drone programs in education. So there's a definite need within universities to manage that bureaucracy so that you can find those people who will champion that program. It's not just starting up a new GIS course. It really is much more involved due to everything from risk management to insurance. Partnerships are key on that, and I think we heard some strategies for how to do those, figuring out who on campus you can help by perhaps going out and flying a specific area. Maybe it's a construction site or a building, any of those types of activities that you can do. Folks are struggling with these sort of end-to-end workflow type things. And I think the exciting thing with the new software is that we finally have some solutions that will take you through everything from flight planning to approval, all the way through to the processing and moving things to the cloud. We heard concerns about software, specifically the number of software packages we need to use, the fact that those software packages are cumbersome on the desktop. And so we saw some great examples of how things like SiteScan are moving things into the cloud. So we're not just sitting around waiting for the photogrammetric processing. I think there's also a recognition that we can keep things simple, and doing things simple with low-cost drones and really taking advantage of their strengths, specifically the spatial resolution and the temporal resolution. And we don't need to get wrapped up with running perhaps cutting-edge LiDAR sensors or hyperspectral sensors or even multispectral sensors. We've got to help our students understand the unique role that drones play and the advantages that they offer compared to some of the other platforms out there. And then finally, a strong desire, I think, to share knowledge and lessons learned. And so Lane and I will be working on an Esri blog post together that we hope will provide some insights into how to kickstart your drone program and to deal with some of these issues.
Thank you. Thank you, Charlotte. That's an excellent summary. I agree as well. It's a lot of the challenges that some of them easy, but some of them it's kind of like difficult to overcome. But I think through the experience, come advice, best practices, especially for those that just started, want to plan to offer the drone training. So I have a question in here. I see that some programs that only offer drone pilot course. Okay, how important do you think to include actually GIS or geospatial topics or skills into these drone classes?
I think it's absolutely crucial, right? When we think about why are we flying the drone in the first place, we need to keep in mind that if we don't turn those data into useful information, what's the purpose of going out there? And it's no secret that we need to have qualified and experienced pilots, especially when we're operating in challenging situations. But I think we do a disservice by just divorcing the flight operations from the downstream data workflows.
Yeah, I completely agree with that. That is very important that, and not only that you know how to fly it, but also it's equally important that how to process it to become the information product, right? So the other question that I have in mind, you see that it's a lot of programs offering now the drone pilot and drone processing. Do you think it has been saturated, the offer in United States, or the demand still higher for the supply of this skill?
Yeah, I think on some level it is saturated. If we look at sort of the number of Part 107 preparatory courses out there, I think what's not saturated and what's lacking are courses and programs that really integrate drone technology with the specific domain application. One of my least successful projects was very, very early on in our drone operations, where we went out and did a bridge inspection. And what we did was we just unloaded massive amounts of data on the bridge inspectors. And what they came back to us and said, you know, when we did a bridge inspection 5 years ago, we filled out the sheet of paper. You've given us a point cloud, you've given us all these images. We have no idea what to do with all these data. And it made me realize that I'm not a bridge inspector, and that the people who need to do that type of work need to have a whole host of skills. And flying the drone and processing the drone data may not be the most difficult skills to develop. It's some of those ones that are domain expertise. So I think the best thing that we can do is integrate drone technology into our civil engineering programs, into our environmental science programs, and into our historical preservation programs, where we can couple the technology with the specific applications.
I completely agree with you, Joel. Tommy and Margaret, do you want to add into that?
So we do integrate some, sometimes it's just a drone demonstration. Sometimes it's lectures, sometimes using imagery that maybe Tommy already acquired of an interesting place like coastal marshes in Georgia, looking at soil erosion after hurricanes, looking at archaeological sites. So I'm stealing your thunder, Tommy. You might want to talk about that. But there's a lot of interest in a variety of classes that we teach.
Yeah, well, you know, and it's we've always believed in all the work that we've done at UGA, and it's easier to teach someone how to interpret a photograph or how to fly a drone than to teach them domain knowledge. And we did, one of the things that we've done at UGA is I think it was 28 national parks, the vegetation, very, very detailed vegetation from aerial photographs. And there's no way, I'm really good with aerial photographs, right? Okay, I'm a certified photogrammetrist, all that stuff. I know nothing about vegetation. I could never have done that. I could manage the GIS, I'm good with that, but we had botanists, and we taught them how to, they knew what they were looking at on the ground. We taught them what it looked like on the aerial photographs. They did the mapping. It's much easier to have a domain expert and teach them the skills they need, you know, to do the work. I did a roof inspection, Jarlath, with a drone, and I kind of knew what I was looking at. But again, I threw a bunch of photographs at the actual roof inspectors, and they said, "Huh, I think we're going to climb up there and see what we're going to look at." So it's, again, the domain knowledge is more important, but you still have to be able to have some skills for flying these things, because there's different ways to do it.
Skill in flying the drone and also domain knowledge. That's really good package. Awesome. Thank you so much, Joel, and Tommy and Margaret for the first group, working group summary on that. Very good point. Now we're going to move on to the result of the second working groups on the topic of remote sensing, the foundation of 3D capture and reality mapping. For that, I would like to invite Dr. Tommy Jordan.
Okay, well, I'm going to share my screen. I've got a few slides too here. Let's see if I can make it work.
Please do. We can see that. All you need to just play it.
Is it working?
Play it from this.
There it goes.
Slide, please. Yes.
Okay.
Awesome.
So the panel we had yesterday included Caroline Tyra and Lee Brenton as kind of the Esri experts. Kira Morris was an outstanding moderator. Today, our moderator is Kanserina Kerna, who you've been listening to and seeing. We had a few takeaways that from the session that I want to just kind of run through. The poll results, data sources, 3D base maps, reality maps, and digital twins. And I tell you, some of this stuff was new to me. I'd never heard of a digital twin before, and I thought it was really cool. All results, we asked what was the value of having your data in 3D, and more people said for better visualization, improved decision making. It's cool was the cool answer, but it actually fits pretty much every situation. But and then the data sources, people were using kind of the instant or the already 3D data, LiDAR and DEMs, more so than actually generating their 3D data from drones or aerial photography. And that's probably not that surprising. One of the things, one of the things that about the data sources, that most were using the data sources are LiDAR and DEMs, followed by drones and aerial photographs. But in the conversation, it came out that really the data source selection depends on the scale and the application that you need, that you're using this for. And then what is actually the final product? What are you trying to, what information are you trying to get? And from that comes, well, what data do we need to use? And really, no matter what the client says, more detail adds cost, but it's not always needed. Now, I guess if the client wants to pay for it, we can spend the time in the computing costs and generating more aerial photographs, but it's not always a win-win situation. 3D base maps was something new to me yesterday too, although it makes perfect sense. This is a product that is available from Esri, and it can be used to author and maintain a 3D base map for your organization. And the actual tool provides a series of workflows that can streamline the creation and maintenance of a 3D base map so that you can support diverse information needs. Although it comes with canned data, it also allows you to plug in your own data so that you can use it in your own situation. You can use the canned data to learn how to do it, see what the possibilities are and what the capabilities are, and then plug in your own data to fill in the blanks. And it makes it more it just makes it more personal, I guess. And also then you can use it, because you can't really use canned data to manage your city or your campus or whatever it is. Reality maps, this is cool. Now this is something I've really always been interested in. I've because of my drone experience, because of my aerial photographs and my photogrammetry and whatnot, but it's really going to the next level. This is something that Peter Becker talked about a few minutes ago, but within the Esri, what they're calling the Esri ecosystem, now there are some tools that can take you pretty much from start to finish on here. We're starting with flight planning with site scan, drone to map for using drone images, and ortho mapping for using conventional aerial photography. And then you can throw the whole thing into this new product that is just going to come online soon by a company out of, I think they're from Stuttgart, they're from Germany, called N-Frames, and the product is called Shure. And I've been watching these guys for a couple of years, and when their product create these 3D meshes like you're seeing in that image there are just spectacular. They're really, really good. And what that can lead you to is digital twins, where we have a virtual representation of the free world. I mean, of the free world, of the real world, including physical objects, processes, relationships, and behaviors. And the GIS provides the foundation. We have the 3D information on top of it, but then you've also got all of the other information that underlies that, which creates a much more rich information environment. It can also represent present, past, or future conditions, which makes me happy since I do a lot with cultural GIS and historical sites and whatnot. Somebody asked yesterday if you can have a digital twin of a farm. And well, I haven't done a farm, but what we did do is we did point clouds of a collard green garden. So these are collards are very popular in the South. They're hardy, and they have big leafy greens on them. And so this is a point cloud, which would lead to, I guess, a digital twin of a collard garden. And by extension, we could do that to a farm to monitor yield and production and throw in these things. If we were to do this we've also had a product where we were making these gardens, making images of the gardens, 3D models throughout the growing season, which leads you then to being able to have yield models and productivity models. The problem, though, is registering these 3D data sets. And I think that this is an ongoing issue that we've got. How do you register with precision these 3D data sets for multi-temporal studies in such a way that the error or the differences that you measure are actually true differences and not just misregistration errors? And that's not something we talked about, but that's something I think about a lot. Finally, there are a series of resources, and Kanserina put them up in her blog. She's also going to copy them to the chat box, and about the digital twin and 3D maps, 3D base maps, ArcGIS Urban, and then some information about the N-Frames and Sure material. And it's very interesting. And Kanserina, when you put it up there, I hope everyone will be sure to copy it and save it so they can look it up later.
Thank you, Tommy. I did put it in the chat for everyone. Feel free to open that. Great points all. It's interesting how the remote sensing 3D and reality mapping are now integrated, and having them all in one technology platform, it's really helped. Okay. I'm glad you mentioned, I'm glad you also mentioned about the Sure surface reality. Again, we acquired it, Esri acquired it on 2020. Then Stuttgart teams are now Esri R&D office, and we are very exciting, and we have more news in 2021. Okay. Before I move to the last working group, I have a question to you. How do you see this integration incorporated more in teaching and research? What important other than impressive visualization and look cool?
Well, a lot of what we're doing is just, how much time do we have? That's the biggest deal. The semesters are short. Attention spans are not so long either. But the biggest deal we're going to have is how do we go past the point cloud? How do we turn that point cloud into information? We talk about decision-making process as being, data into data into information into decision-making or something like that. And that's the hard part. How do you convert these point clouds and these beautiful images that you create into actionable intelligence or decision-making thing? And I think that's what we need to work on more. And the advanced students get it. But usually if they're working on it for, their thesis or their dissertation, they have time to actually go to that point. But I'm not sure that everybody does get that.
Very good points. We all agree with that. Thank you so much, Tommy. Last but not least, we're going to move to the third discussion group with the topic on GeoAI, recognizing opportunities and challenges, utilizing GeoAI for education. For that, I would like to invite Dr. Margaret Madden.
Okay, thank you. Just get my presentation up here.
Awesome.
They look good? Okay. So we had our GeoAI working group members here. Mansour Riyad was the moderator. Myself, Omar Meher, Greg Brenner, and David Yu. So there were some questions in the chat that gave me the idea that people are really still a little bit confused about what GeoAI is. So I found this really good quote from Jay Theodore, and that was at the Esri Developer Summit this year. So geospatial AI, artificial intelligence, applies spatial machine learning and deep learning techniques to help solve complex problems and derive deeper insights in powerful and innovative ways. So very conceptually, but also it expands the power of GIS to support human in the loop and autonomous systems. So I really like that part because I always like to bring the person, their experience, their knowledge into any kind of image analysis. And then a little bit further, machine learning is using data-driven algorithms to learn something from the data, and you have to put that data in for training and also for validating the models. So you can see that the samples or the input data sets are extremely important. And then deep learning would be a subset of machine learning using deep in quotes, which is really a layered neural network algorithms, and that's inspired by our neural connections that are in our human brains. So going over our poll results, we had 130 responses. So are you teaching a program that implements the GeoAI techniques? And just under 20% said yes. 30% are planning it, but over 50% no. So there's potential there. There's, we need to find out what is the barrier, what are the barriers to that, and how can that be helped if there's interest and people would like to do it. And for those who are implementing GeoAI, what level of students do you teach? And I was surprised. I thought it would be mainly graduate students, but really split graduate and undergraduate students. And then a big group of other. So I would be interested in knowing what the other students are in that category. And then what does your GeoAI focus on? Kind of as expected for me, that classification would be the main use, but then also feature extraction followed by predictions, and then a pretty hefty other category. Again, that'd be interesting to know what that is. And then what type of data are you using for teaching and research in GeoAI? Aerial imagery, so high resolution imagery, that makes me think. And then also LiDAR and vector data, and to a lesser extent the bathymetry, and no video at all. So some potential growth in those areas. Then, so in our discussion, we all agreed that there was a lot of excitement and interest in GeoAI, but need for training both of the educators and then the students in academia. And we all liked Mansour's quote, "These days we are data janitors, cleaning and preparing data." So since these are data-driven algorithms, there's a lot of work on the data management side. And then although challenging, we do need to commit to think about working with arrays and matrices, which may be new to students, using maybe Python or some other programming languages. And this would be especially true in advanced courses when they would really like to branch out and do their own independent work. Some other challenges is assembling and labeling those training and validation data. That remains a challenge. It is critical to the success of the machine learning and deep learning models. And then there could be some barriers with infrastructure and computational needs. So there are a number of responses to that, and I was really glad to learn about the deep learning packages that are available in the Living Atlas. So the training sets are already created, and they can be used for a number of different applications are provided, for building. We saw some demonstrations about that, the building footprints, it's things like shipwrecks, and then also classification of different types of features. And then once maybe student and educators get used to that, then they could be customized with your own local imagery data. And I always like to bring my lessons and exercises back to places where the students are familiar. So I have them work with campus imagery, or I say, what's your favorite place in the world, or where's your hometown? So really bringing it back to places that they know. And then there are a lot of Esri cloud-based processing capabilities that are coming on all along, some in the future, but ArcGIS API for Python is there, ArcGIS Learn, and then ArcGIS notebooks. So we've already got the notebook environment, ArcPy, you're able to access all the geospatial processing tools. And then if educators or students are already familiar with other frameworks, the scikit-learn or TensorFlow, R, Jupyter notebook, you can also integrate with those. So a number of different options. So pulling just a few things out of the Q&A, one was that the AI ML still seems like smoke and mirrors. Some of the AI explanations are still confusing. How is it different from spatial analysis and modeling? And then are there training and teaching materials available at Esri that educators can use, examples and some galleries? So it's great to see that Kansarina did post the blog that was already mentioned. So a lot of resources here online, and click on the section for Working Group 3 for the Geo AI resources, and there's a number of different links, and I'm really looking forward to diving into these a little bit more. And then just finally leaving with a couple of the hard questions, and these are more advanced users who have found some issues with version differences, maybe between the ArcGIS Learn module and the other packages that are integrated. And then an interesting question came from Dirk Tiede from University of Salzburg. Instead of applying frameworks from the computer vision community only, could GeoAI be extended to include our history of spatial reasoning and other geospatial knowledge, including prior knowledge about geographical conditions, etc., already in deep learning and prediction processes? So I think there's always going to be interest and I know Esri is very responsive when users have suggestions and points are raised. Great at responding to them and adding to your suite of capabilities. So I'll end there.
Thank you so much. Thank you so much, Margaret. It's really great to end it with such thoughts on that. Thank you. I believe with all the resources that we have, we can see growing more and more that teaching and research will adopt the GeoAI technology. This is all the time that we have. Thank you so much again for all the panelists, academic leads, all this inspiring for us in the educator community. And Jarla, thank you for bringing Thumbelina. That was a treat for us. I return it back to Jerry now, please.
Indeed, it was wonderful to see Thumbelina. Nice welcome break. So thank you to all the colleagues that just spoke. Wonderful insights from all the working groups as a follow-up. And with that, I would like to continue with our closing session. I know a couple of you are going to come back on to continue some of the discussions. Basically, revisit some of the key themes and concepts and things learned from the conference, and of course, cover things that are near and dear to us as educators, things that keep us up at night, that is challenges and so on. So Dr. Dawn Wright is going to moderate this session for us. I don't think she needs an introduction. She's our fearless chief scientist. Hey, Dawn. Wonderful to see you. And so yeah, wonderful work. Dr. Dawn Wright was just, by the way, nominated to the Academy of National Sciences. So congratulations for that election. And she's done a phenomenal work in many different areas, as you all know, just pioneer at heart with her work in oceanography and marine GIS and geography in general, all the research that she's done. And also, I don't know if many of you know this, but about, she's also a pioneer in online learning in a sense. So 20 years ago or so, on a personal note, I took a class with Dr. Wright at Oregon State University, one of the very first online GIS classes. So she has enabled many, many students, many other educators as well. And with that, Dawn, I'll let you take it over.
All right. Thank you so much, Jerry. I am so pleased and honored to be moderating this final session here. Congratulations to all of you for a very successful summit. And it's my great pleasure to introduce our panelists for this closing discussion. Jarlath O'Neill Dunn, perhaps with or without Thumbelina from the University of Vermont. Marguerite Madden, who you just heard from, the University of Georgia. Karen Schuchman from Penn State University. Joseph Kursky, our colleague at Esri, and also the new Lifetime Achievement awardee by the UCGIS for education. And Delphine Khanna, also of Esri. So we are going to have a very stimulating conversation now, and it is going to be conversational. What I'm going to do now is to share my screen so that you can get an idea of the topics that we would like to undertake here. Now, before I even go through all of these topics, with these types of discussions, there are many, many more topics that we could take on, but we most definitely wanted to key in on access and equity in education, especially in terms of how best to include all of these amazing emerging technologies, especially given financial constraints and other digital divide issues. We hope to also touch on what should actually be taught in the classroom, in the modern remote sensing classroom, and that includes the digital online classroom, as well as modern remote sensing programs to best prepare students for the future. What about theory and practice? How do you balance theory and practical skill building? And in what mode? We know things cannot be just linear the way that they have been in the past. How important is face-to-face versus online? That is the fundamental question of the age right now. And very closely related to that, what is the obstacle or the benefit to learning software as part of our curricula? And then finally, what new tools and workflows should be embraced in light of the rapid evolution of remote sensing technology? So these are some of the questions that we would like to undertake. I hope that we will actually branch off into other topics that interleave with these questions. We have about an hour for this engaging discussion. So what I would like to do is really to focus first on that first question, access and equity, especially given Marguerite's report from her breakout group on GeoAI and those very advanced technologies and concepts. How do we best ensure that no student is left behind? What can we do in terms of helping students, departments, small universities and colleges, small units with financial constraints? There are other digital divide issues that will come up in this discussion, but I would like to ask Jarlath to lead off this discussion, especially since we are going to lose him in approximately 15 minutes so that he can get his second vaccination. So Jarlath, could you please continue with us before you depart and start us off on that question.
Yeah, thank you so much, Dawn. And let me add my congratulations to you for being appointed to the National Academy. So well deserved, and it's a real honor to be with you. And I think COVID-19, for those of us in education, we found that the equity issue really surfaced quickly, right? We maybe had to move to online teaching, and we saw situations in which students with the fancy laptops or the money to buy computers could suddenly run the software we need. And our university, this was helpful because it forced us to move to virtualization. And the virtualization, what it allows us to do is it really allows students with any computer to log on anywhere and have access to our full suite of geospatial technology that they need to complete their assignments. And I think at the same time, we've seen many of the Esri technologies move into the cloud that I think will improve our access to the tools that our students need to complete their assignments and remove many of these equity barriers that have existed for such a long time. They'll still remain. There'll be things around bandwidth. There'll be things around building those virtual systems, but I do think we're getting closer so that we can improve the use of geospatial technology in our classrooms among all of our students.
Great, Jarlath. How about the other panelists? Anything to add to that? Marguerite, especially given your breakout group that you've just reported on, thinks a lot of salient issues there.
Yes, I would just, we had a similar experience here at UGA, and I would add to that a positive outcome of this pandemic is all the internships became remote. So for example, we're a node for the NASA Develop program, and the diversity of our participants was so exciting. People who never would have been able to move to Athens and be here for 10 weeks for an internship were able to participate. What I have found that I'm building the rapport with individuals and having them connected with our university through an internship, which is, even if it's remote, then they have assimilated into our graduate program. So we have had at least 4 or 5 new incoming students coming as a result of that. So I think that we'll be seeing more opportunities and more diversity because of our online cloud processing and VPN capabilities.
Mm-hmm. That's excellent, Marguerite. And I liked what you had to say about internships as well, because that brings us to the idea of relationships between students and faculty, industry providers or government providers or nonprofit providers who are employing or taking on our students in these internships, which is another means of access and equity as well. And so, Karen, I wondered if you could comment further on that, because you've had some wonderful things to say about this idea of relationship building within these rubrics. What are your thoughts?
Sure. I want to make one comment on the prior topic, if that's okay, just with respect to the equity and so on. Just that, I've been teaching online for a long time, which does then flavor my opinion about developing relationships, which I'll get to. But we also have to, I've experienced for all this time teaching online that we do have times when we have students who they can't maintain internet access at all times. So as we think about moving more things to the cloud and moving more virtual, using more virtual machines and that kind of thing, also bear in mind that we need to maintain some level of teaching materials, I think, that can be utilized in an offline situation. I find that we have a lot of our students are in the military and end up being or they're in secure environments, and they end up not being able to have the kind of internet access that we're talking about as, providing more of these resources. So just note on that. But to the question that you asked about relationships, I think, my point was that, we learn a lot from reading material and going through tutorials and so on and so forth. And, a lot of us are, especially now, learning more and using more teaching resources by finding things online and pulling them together into a curriculum or a course, and relying on those bits and pieces to sort of pull together a coherent course or a coherent learning experience. But we need to be aware of the gaps that get left behind as people learn through assimilating all these bits and pieces. They might miss concepts or not even realize that they've missed a concept. And that's where the relationship between the instructor and the student, or either relationships between students, becomes kind of important. That when you have conversation, or you look at each other's work, or you share ideas about how to solve a problem, you bring more of that to light. So we've all been challenged in this virtual environment to try to replicate the kind of relationships that we're used to having in a face-to-face classroom. I've been teaching online for 15 years, so I've always been forced to develop relationships online, and I think it is very doable, but it's different. I think that the pandemic really removed a lot of everyone's attitudinal barriers to forming long distance relationships. But it's really important that as we move forward and we try to, together as this academy, trying to move our education forward, provide some sort of containers and some sort of environments where we can facilitate these virtual relationships between not only instructors and students, but between ourselves as instructors. I don't want to go on too long, but I think, and one other thing I said was that, more than having all the right answers all the time to the questions that are asked you, it's probably more important ultimately to know when you don't know the answer and have a resource, have someone to go to, a colleague or a friend or a mentor. And we need to make sure that we provide ways to continue that kind of relationship building as we go forward, trying to master all of this technology.
Mm-hmm. Excellent, Karen. Thank you so much, because there are so many things there that will sprinkle down into the rest of our conversation throughout this closing session. I want to give my Esri colleagues, Joseph and Delphine, a chance to respond to this access and equity issue as well, because for us at Esri, this is paramount. So I'm sure both of you have terrific input to give there. I'll let either one of you chime in on this and make sure that the other colleague steps in as well.
Okay.
Go for it, Delphine.
Okay, thanks. First of all, I wanted to say that I got my EGS master's a few years ago at Penn State in the Karen's program and with the virtual campus, and I thought it worked really well. So just wanting to mention that. So this is an issue we definitely hear a lot about in the LearnRGS team, and so definitely the point that Karen made, that it's not, so yes, it can be a problem of not having the processing power on your machine, but it can also be a question of bandwidth. So I'm not sure there is like a one size fits all. So I do think that as we are seeing, especially more and more abilities to do processing of remote sensing in the cloud, it's going to be really great. But we also try in our lessons to sort of make a balance or offer a variety of lesson types, and having simply data sets that you can download ahead of time and, maybe take a long time to download. When people are face to face, like not in a pandemic kind of situation, but it can also be possible for people, let's say, in the developing world who don't have great bandwidth, even in their lab on the university, to download all the data ahead of time. And then this way, maybe it takes the whole night, but then the students can actually access it in the lab. So that's another aspect. So definitely thinking about all the different ways in which there can be limitations.
Mm-hmm. Yes, I think this is really going to be exciting, especially as we develop our Kubernetes technology with that idea of containerization. Which can be transported from location to location, and the idea of an intranet of sorts, as well as an internet, Joseph, what do you think about that, especially with all the many ways that you provide access to marvelous teaching resources?
Well, thanks all. I think this discussion speaks to a couple of things. One, we're teaching with an inquiry-based method, right? GIS has always been a thinker's tool. It's inherently more difficult and challenging than, frankly, just asking your students to memorize a big block of content and regurgitate it for the test, right? That's all what gives us this sort of, that makes us twitchy about education. We don't want that. And I think it speaks to the resilience of the remote sensing, geotechnology education community, that we are creative in the ways that we adjust as we get challenges thrown at us. And a personal story on that, Cancerina and I were working with some students at UC San Diego a year ago when all the disruption first happened. These were data science students. So of course they wanted lots of variables, they wanted tessellations and lots of other things. But speaking to Dr. Schuchman's point, they knew that we were all about their learning. And so we had this relationship with them. And so when we made adjustments to when they went off campus, and like all of you are talking about, you know what's coming next, it's bandwidth issues. Some people went back to other countries to continue their education that semester. Anyway, the point is, knowing that we were really passionate about what they were learning and not the number of variables and so on, we made adjustments, as you all do. Reducing the number of variables, reducing the study area, reducing the complexity of the workflow, and it worked. But all of that it takes time. It does, and it takes the personal relationships that you all are talking about. All this is to say that I salute you all. It is frankly easier to do other kinds of education, but just capping off this discussion, the GIS education community, we need each other, right? We need to be in close contact to share best practices when stuff like this happens, and it will continue to happen. But I think it does speak to the creativity of the education community here, and also what kind of adjustments need to be made at certain points when your workflow and your educational plan doesn't work out quite the way you want it.
Yes, so true, Joseph, so true. Speaking of adjustments, we are going to let Jarlath depart from us now, as much as we hate to do that, and with Thumbelina as well. Go well, Jarlath. Be healthy.
Thanks so much. Really enjoyed being with you all.
Thank you so much. And so I also want to continue on because, Joseph, I really appreciate the point that you made about this takes work. All of us as educators, we work our heads off. We give everything, and it's equally more so difficult in the GIS sector, the GIS and remote sensing sector, with all of the technologies that are part of that. So to me, that begs another one of our questions. What really should be taught in a modern remote sensing course or program to prepare students for the future? I know we're talking about fundamental principles here, so I think we all agree that there should be treatment of the electromagnetic spectrum, atmospheric effects, scale, elements of image interpretation, LiDAR. What else? Digital image processing and analysis, spatial statistics, programming, drone image LiDAR data acquisition, management and analysis, 3D, 4D, others. Given that we have limited time, many of us have limited bandwidth in terms of our teaching loads. What is the silver bullet? And I'm saying that facetiously because there is no silver bullet, of course. But who would like to jump in first in terms of what should be the content? What is the way forward there?
I'll just add one thing to the list that you already, which was quite a list. But being a photogrammetrist, I would add elements of positional accuracy or the spatial characteristics of data. I think that gets really, there's a lot of, there's a lot of assumption, we just assume that data is positionally correct. And Lori told me an interesting story the other day when we were just chatting about in his early days showing some imagery to people in your organization whose names I won't mention, and just saying, when the vectors and the imagery didn't line up, which is correct. They're like, oh, well, these vectors are perfect. So this imagery, there must be something wrong with the imagery. And the more we get into data fusion and so on, and the more detailed and high resolution the data gets, it's really important for people to understand principles of, spatial reference systems and the internal positional accuracy of these data sets.
Absolutely. And I think that's a great point, Karen, because sometimes we do have the capability to include all of these topics. Other times we have to depend in a relationship with our fellow faculty who may be teaching a photogrammetry course that we might make as a prerequisite for our general remote sensing course. So I think there are all kinds of variations on the theme. What do others think? Marguerite, how about you?
So I know that in some colleges, some universities, you may be the one-stop shop, and that's really hard because you have to do everything. My experience working with Ann Johnson and others with the Geotech Center, a lot of community colleges, they find themselves in that position. So they created the Geotech Center and the online resources for them. If you have the privilege of being in a department like mine where we have, not a lot, but we have 4 or 5 people teaching these kinds of courses, then you can build and you can also repeat some of the same material. I find that's okay if you cover the same topics in a couple of different courses. So we have some intro to GIS and some advanced and GIS for health and that kind of line, and then we have introduction of remote sensing of environment, and then digital image processing and field methods of spectral reflectance. And then my course is aerial photographs and more in line with what Karen just mentioned, the photogrammetry. So we offer a GI science certificate that encourages students to take at least as many of those as possible. So I feel like that's a little bit more well-rounded, and that's been helpful.
Mm-hmm. Yes, it's such an important point, Marguerite. I'm so glad you brought that up in terms of course, there's no one size that fits all, and some of us are in small departments. I really would like there to be an article or a talk or something that talks about the one-stop shop professor, because there's so many of us who have been in that category, and people are using the term unicorn these days. And I think among the total professoriate, and this is including community colleges, that one-stop shop professor is really unique and worthy of tenure more quickly. I'm going to go off script a little bit here. Worthy of pay raises, worthy of breakfast in bed, everything. Anyway. But to get to my Esri colleagues, in terms of content, what should be taught, and speaking as a one-stop shop professor for a little while at my institution, the Esri technology, the Esri resources were so valuable in bringing in these important topics that I just did not have perhaps the time or certainly the expertise. So Delphine, maybe you'd like to comment there, especially with what's going on with Learn, with our Learn ArcGIS curricula.
Yeah, so I presented it a little bit earlier in a very brief presentation, but definitely, so one thing I wanted to comment on is that when we started with wanting to develop this website, this curriculum, we basically did a curriculum analysis, and one thing that was so fascinating is how various universities really slice and dice the whole domain of imagery and remote sensing so differently in terms of what course series there is, etc. And so that was really very interesting. We did decide to provide a sort of like buffet style approach because we did realize there was it wouldn't work to just say, okay, here's what you have to teach, this followed by that, but we did try to cover a number of important topics. We obviously, imagery and remote sensing is such a vast domain that there is no way you can cover it all, right? So we did try to choose some salient topics, and we did try to create some kind of balance between sort of the fundamentals of like how do you work with indices and band combinations and things like that. We do have, for instance, talking about image classification. How do you assess the quality of image classification? Things like that, but also try to offer some intro level workflows on how do you work with LiDAR and create some interesting 3D visualization, or how do you work with drone imagery, not creating the flight plan yourself, but once you have the imagery, actually working with it and doing some interesting analysis with it. So trying to find this balance is the perspective we took, and hopefully the higher ed community will find it useful, and we definitely would like to get your feedback. And perhaps one last thing I'll say is that no, I think I'll stop here. We're looking forward to getting your feedback on this balance and trying to have a bit of proposing a variety of things.
That's great, Delphine. Thank you. And what I love about that project is that it's going to evolve. It's going to change and grow and be ever so more valuable to various aspects of our, I'll continue to say, professoriate across the community college to the 4-year university spectrum, and to other professional programs as well. And to that end, Joseph, I wondered what your perspective is on this, given that you, of course, are with us and work for Esri, but you are also a functioning professor who teaches courses at, how many universities is it? 5 or 6? I know that you're at the University of Denver, but there are other places where you are actually teaching, a teaching faculty member. So what's your perspective there on what should be taught?
Well, thanks, Dr. Wright. I mean, many of my colleagues here at Esri, we, like the community that's in the conference today and yesterday, we love teaching, we love interacting with students. So we're very passionate about it, and I'm happy to be a part of the community as well. Dr. Wright, I keep thinking that there was an article called Lonely Geographers. Now, it was just geography professors, but it was geographers that were in universities as the only geographer at the university. This is going way back. This was in UBEAK from the American Geographical Society some years ago. I can't even find it online. I was just doing a search. But anyway, but your point is well taken. I think we need to dust off maybe some of those ideas in that article if we can find it, and someone write an article about the lonely geotechnology professor. I think, especially in these modern times, that would be very instructive, the challenges that they go through. Okay, so to your question, first of all, I think that my impression on this community over these years is we all really love creating our own curriculum. That's one of the reasons why we got into education. It's that creative process, and that's going to continue. However, this came up in our Ed Summit last August, the Esri Education Summit, where a couple of faculty were saying, is it less noble of me to actually use some of the resources, for example, that Delphine's team have created? And a number of us, Jerry and I and others, responded by saying, no, it's no shame on you as a professor to use these resources. Number one, because of some of the things we've talked about in the last 2 days. With the variety of tools, it is vastly different from those days that some of us remember when there was kind of one way of teaching geotechnologies with some variation, but there was sort of a pathway and a set of resources. And now we've got this, I mean, I'm thinking about some of the slides that were shown today, this plethora of tools and resources, and we can't do it all. We shouldn't do it all because the students will just get this mini bite-sized gluten-free piece of each thing. And so we have to, of course, look at our course objectives, program objectives, university objectives, and pick and choose what will be the most valuable for the students to learn about. And so with that, once we decide that, yes, I think one of the messages is that we should not create our own curricular items for every single one of those. We simply don't have time and we don't have the expertise. So these other resources, I think, would be very valuable. And the second thing that I wanted to share about that to your question, I think that the days of scripting everything in these long labs that we all had for years, in times past, that was the only thing students had, right? They're your labs. And so you had to put, okay, now we're getting to the section where you have to georeference. Here's how to do that. That's all they had. But now they get to that section and you can say, okay, if you don't know how to georeference, here's a video, or the students are quite resourceful. They'll go out and find, it's like you fixing your sink at home. You watch the sink video, in my case, 15 times before I understand how to do it. But the point is, I know this is difficult, and I've got plenty of long labs like this where you've got all but as we know, the rapid pace of change is going to require us to curate all that every time the quarterly update to ArcGIS Online, for example, comes out. And so I'm just trying to nudge the community into thinking, okay, maybe the time is opportune for me to make those lessons shorter and take advantage of the collective wisdom out there, the collective resources that are out there. I realize it's difficult. I have like a 40-page go to census.gov lab, and then do the join. I think probably all of us have a variation on that. But now you've got the popular demographics inside ArcGIS Online, for example. And there are other ways to teach joining. I'm not saying it's not important, but the days of having, I did it and it built character, and therefore my students need to do it. You know what I mean? Maybe we don't need to do that. So those are a couple thoughts as we sort of navigate these sort of choppy waters, understandably.
Yes. What is there? I have a poster on my wall that my mother gave me. I'm not afraid of storms, for I'm learning how to sail my ship. So that's where we are for sure. Thank you, Joseph. And it leads perfectly into the Q&A. I'm going to go over to the Q&A now and have us react there. I love what Shannon has written. This is my life, Dr. Kursky. So that she definitely, it definitely is resonating. And our venerable past president of the UCGIS, Karen Kemp, says and this should also be a poster on the wall. The most important thing to teach your students is how to learn for the rest of their lives. And so that's regardless of the topic. So thank you, Karen, as always. And George has mentioned here that map accuracy assessment is an important topic to cover with students, for sure. Peter asks, very wisely, should we actually revisit the geospatial technology competency model to incorporate new technology? And I think part of that is also the UCGIS GIS and T, Geographic Information Science and Technology body of knowledge. Any thoughts from the panel on revisiting either the competency model or the body of knowledge?
It's been a while since it's been revised, because I recall participating when David DiBiase led that, and it's been it's been a while. And I know even at that time there was there could I think a lot of us in the remote sensing community felt like there could have been a more robust treatment of remote sensing. And so yes, I think of revisiting that would be appropriate, and also including more things that are relevant to UAS as well.
Mm-hmm.
Yeah, I do remember also how much work that was. So, you know, it's been through it a few times, and I don't know. I would love to, if there was some new fresh people who want to come in and work on that, and maybe it is important. So maybe if there was some funding to help support that initiative. It's used internationally. It's really important. Mm-hmm. Based on a lot of interviews, a lot of data crunching, talking to people, what do you do in your job, and what do you need to know, and it's changed. You're absolutely right.
Well, there's so much going on, and I see here. Thank you to Roberta, because she has just reported that the Geotech, I'm assuming this is the Geotech Center, has just prepared a survey that does address those competencies, and it was distributed this morning prior to the upcoming meeting. So we'll definitely thank you, Roberta, and we'll definitely look forward to that as well. Yeah. And I wanted to thank you, Michelle, one of my finest students ever, and one of my favorite educators. Michelle, I'm going to just call you out here on the storm reference. I am not afraid of the storm because I am the storm. That's right, Michelle. Good shipmate. So I'm going to, I want to go up to Sumit, if I'm pronouncing your name correctly, came in very early with a very nice insight. The learning of geospatial technologies has a major component of active learning and peer-to-peer learning based on group inquiry. In my experience, Esri has always excelled in such learning, but now in the remote learning, it is quite a challenge. So maybe Karen, since your teaching is it's exclusively e-learning, did you mention? What are your thoughts on that, active versus peer-to-peer?
Yeah, that definitely is a challenge in the online environment. We've in our program we find it does get difficult to do things like group projects. We try to have peer review of certain, peer-to-peer review of certain products, like as the students develop their individual projects throughout the semester. We have but it's mostly asynchronous, because we have people that are in literally like time zones around the world all participating in the same course. So yeah, that is definitely challenging. But I think people are just, people have gotten so much better at it in this last year. And spending time in Zoom and getting a lot more comfortable with the collaborative tools to do peer review, or peer-to-peer collaboration.
And Marguerite, at the University of Georgia, how is it there? Because I understand that there's a mix of online and when campuses are open from the pandemic, face to face. How is it there with the active and the peer-to-peer, with that mixture?
So we have always been a hybrid instructional model, but very few students came into the classroom in the fall, more in the spring. So it was more virtual, and one phenomenon I noted, because I wasn't ready to change all of my exams to be online. So I gave everybody projects. So everybody in my 2 classes were doing group projects, and they did have to interact virtually. Turns out every professor on campus probably did that, and they were all overloaded with projects. But another thing I observed with the NASA Develop groups is that they found ways to be able to do somewhat of a peer-to-peer. It wasn't the same as being face-to-face, but they would leave their teams or their chats open the whole day. So if they're working for 4 or 5 hours, they knew they were virtually connected and would just have to speak up or send a chat. And so there was always somebody there to answer a question right away. So they built their team rapport that way. We started every day with a check-in and a geo quiz. At the end of the day, we would do some silly drawing games, finding out what's your favorite X, so we got to know each other a little bit that way. It wasn't the same, but we were trying.
Yeah, that's great. Boy, y'all are making me want to go back to the classroom. I want to go to Andy's statement and question here, which I think will be good, especially for Joseph and Delphine to perhaps take on at first. Andy says the data needs to be relatively local to the software for ARC to be functional. And even with high-speed connectivity, pulling data from, example, Google Drive for desktop to use in a local or a cloud application seems too slow. So for example, 30 seconds to load a layer. Any other suggestions? So the idea of the data accessibility. Joseph, I see that you're nodding as well as Delphine, so both of you take it away.
Go ahead, Joseph.
Well, some of you may have noticed yesterday in that quiz that I had, there was a little delay in the tiling of the imagery in those imagery quiz things that I showed. So yeah, stuff happens, even though I had practiced it for weeks and had given that quiz numerous times in the past. At that particular hour, there was some delay. So I made some adjustments in what I was going to do with you all, as you probably noticed. I know we don't want to go back to the desktop only days, right? There were all kinds of clunkiness associated with that and that steep learning curve and all the rest of it. So it's wonderful that we have these tools available to us. But there are challenges with the volume and variety of data that we want to consume in these lessons and in these activities with our students and in their projects and internships and so on. This is a huge topic. I would say that in some of the courses and workshops that I've taught over the last year, especially, I have had to do a bit of what I talked about that Ken Serena and I did with UC San Diego, where I reduced the variables in the study area, the resolution of the satellite imagery and other things. I guess I rely on my colleagues here to chip in here. I'm not feeling like I'm adequately addressing. I can feel the pain because I've been there myself numerous times. I was at the University of Illinois once when ArcGIS Online went down. This was about 4 years ago. Maybe some of you remember that day. It was like February 28th, 2017. It was the last time that happened, but I remember it because I had 150 students in the lab. I'm going, what's wrong with the Wi-Fi here? This is a major research institute. So stuff happens. Anyway, I can identify, but I'm going to rely on my colleagues to chip in here.
Delphine?
Yeah, no, I don't think I have the silver bullet as has been mentioned earlier. Yeah, I mean, it's a bit of all of this. I mean, yes, it's an ongoing issue. It's also that we are becoming more and more demanding on how much data we think would be normal to have in a project, including in a student's project meant for students. Like, sure, have this, multispectral data and cover as much extent as possible, and add also this LiDAR on top. So yeah, definitely. But we do try to use a bit of all those tricks mentioned, such as limiting the extent, downsampling when needed, sometimes relying on trying to have the data, like use image services which tile the data as opposed to having the whole thing to needing to display in one go. But yeah, I wouldn't say that it's perfect. It's definitely sort of an ongoing process. But again, it's interesting to see as our capabilities are increasing, our demands are increasing too, because we do want more of that complexity, more of that those images that are just amazing. Now talk for instance about lately we've been working a lot with time series, and multi-dimensional, multispectral data, such as have like this whole series of multispectral images that actually show you the evolution over time. So yeah, we are definitely being more and more demanding. So that is a challenge.
Yes, excellent point, Delphine. Excellent. I'm going to, I think we're going to stay with the question and answer because it's guiding us in so many fantastic areas. And what I'm going to do next is touch on a couple of things here. And then I'm going to turn this fourth question over to Karen, because Karen, you've indicated that you want to answer this question live. So I'll call on you very soon. I just wanted to read out Rui's comment to Joseph. Imagine teaching ArcGIS online in Cape Verde, and Joseph is engaging in a conversation directly with Rui. And I want to acknowledge Roberta's comment here. As Karen noted, never neglect the importance of positional accuracies, going back to that discussion, taught through the principles of photogrammetry and applying to so many remote sensing sensors. And may I add also that this is incredibly important underwater as well, with acoustic sensors. Similarly, both Russ Congleton and Cass Green have established principles for determining classification accuracies, and some things are so basic for accurate analyses of spatially linked data from a diversity of sources to make that data valued as information, knowledge, and wisdom. So curricula cannot ignore that foundation. And thank you very much, Roberta, for that reminder. And then Diana brings up the issue of libraries. And I would like for us to spend a little bit of time on this before we have Karen answer Nishant's question. Libraries are actually beginning to hire more geographers and data scientists. And Diana, this is so true. Diana is in one such position, a GIS research associate faculty member of the FIU GIS Center, which is a division of the libraries. And this, I think, is an extremely important topic, extremely important development, the role of libraries and of data librarians, of GIS staff that are in the library. Joseph has mentioned the Colorado State Geospatial Centroid in the library. UC Riverside has a wonderful library, of course, with Serge Ray's Geospatial Analysis Center there. UCSB has this, and this is actually what Jack Dangerman has mentioned as part of his vision for education of all kinds that's related to GIS, is to incorporate the library perspective. So what are the thoughts of the panel there with regard to using libraries, helping librarians, having librarians help you in doing your instruction?
So we, I really I'm really glad that Diana brought this up, because it's also given our graduates an alternative to going into a typical tenure track position. And we had a very wonderful, talented PhD student who graduated, Doris Scott, and she had built up a relationship with our library through GIS Day. So we have some GIS capability in our library. The library partnered with geography to put on GIS Day, and we did it successfully for a few times. And then Doris went on to have a position similar to Diane's at the University of Washington in St. Louis. So she's there now and really enjoys it a lot. They also have all the historical aerial photographs and maps, so I always bring my class there to hold some data in their hands, some imagery in their hands, because I think that's important too. to see where all the digital imagery comes from.
And I think it's a nice development now that libraries are actually teaching courses, short courses as well. Delphine, did you have a comment to that?
Yeah, I wanted to say that it so happens that in a former professional life, I actually was an academic librarian.
That's right.
On the tech side of things. And so I absolutely love libraries, and I believe they are very, very important in terms of data literacy in general. That is, they are really at this neutral place on campus where everyone can come. That is not just people who are, registered in the GIS program or a data science program to learn sort of the basics of working with data, essentially. And certainly GIS style data is one type of data, and then they would be, working more like with textual data, etc. And this notion that libraries see it as just a development of their mission. Their mission is to give access to information. And nowadays, accessing information is not just taking a book on the off the shelf and reading it, but it's actually taking, among other things, data sets and actually making sense of it, which obviously has to be done with tools, has to be done with methods. And so I'm absolutely 100% a supporter of that, because I do think that while departments such as geography departments or other departments that teach GIS on campus are doing a fantastic job, but I see it as really a way to give like the breadth, like reaching more people, and maybe some of those people will go on to actually doing a full degree or certificate in GIS. So definitely, yes, 100%. And also, I believe, and maybe Joseph will tell us a bit more about that, but that our education team here at Esri is trying to develop more of our connection with librarians who do GIS and connect more with them and support them more.
Absolutely.
Yeah, absolutely. Oh, sorry.
I'll just add that Penn State also has we have a map library in our librarian who's very accomplished in the area of GIS, and he's published or presented a paper last year at the ASPRS conference, and I know he presents papers at librarian conferences that talk about geospatial technology. But he's actually they've asked me to consult on a project to help them orthorectify old NHAP imagery for the entire state of Pennsylvania to distribute through the library system as one of their part of their historical archives. And that actually led me back to talk to your ortho development team, because they needed a way to do that orthorectification they didn't have the money to invest in an expensive photogrammetry production software. And they also needed some software that was accessible enough for student interns who work in the library to be able to do the digitizing and control selection and so on. So it was a great collaboration, and I think it ended up actually giving your ortho team came out and spent a couple days with us at the library, and I like to think that made some contribution to the ortho mapping product that's now in ArcGIS Pro. So.
We love it. Joseph or Marguerite, did you have more to add?
I think Joseph did.
Well, I'll just add a couple of brief points here. First of all, one can think of the goal of the imagery geotechnology community in maybe two ways. The deeper implementation of GIS and spatial thinking and remote sensing in education, the whole notion of the platform, the system, the field tools and the analysis and all the things that we've been chatting about the last 2 days. That's the deeper. In other words, it's not just teaching version X of software Y. And then the second part perhaps could be thought of as the wider implementation of spatial thinking and geotechnologies in the academy, of course, in schools and community colleges, throughout the educational academy, writ large. And the broader part is, as well as the deeper part, but I'm thinking the broader part now is really one of the great roles that these geospatial librarians are playing on campuses, because they're all about breaking down departmental walls. I mean, we all are to some extent, but they are, tasked to do that, work with all kinds of different programs on campus. So it's great working with them And as those positions are, maybe some of us would like them to happen faster, but as these positions are sort of slowly funded and supported, it's great to see how they are very active in the Colorado State University, just being one example, in spreading GIS and spatial thinking and remote sensing throughout different disciplines and doing the trainings like you were touching on, Dr. Wright, and other things that they do, sharing data, setting up hubs, and much more that we could talk about. But it's a very encouraging sign.
Oh, it certainly is. And I think now we are getting together a cadre of our favorite librarians, as Roberta mentions here in the Q&A. Julie Sweetkind Singer, the Associate University Librarian for Science and Engineering Resources at Stanford University, who is also one of the National Geospatial Advisory Committee chairs, a recent chair, so that's other service. Amy Work, who is the GIS librarian at UC San Diego, just a superhero. So this is all wonderful discussion. But I'd like to now turn to Karen to answer Nishant's question that has been languishing for a while. So Karen, take it away.
Oh, well, I'm so excited to see it because, that I think that is something I'm personally really would love to see happen. We get at ASPRS get asked all the time that for photogrammetry 101. It's difficult. It's been very difficult to figure out how to teach it for me at Penn State. For 15 years I've been trying to figure out how to teach photogrammetry to students online without the math, so to speak. And again, finally I have the ortho workflow within ArcGIS Pro, which is it enables me to put students through the workflow. So I'm definitely very interested and would love to help coordinate something like he suggests as a master program in photogrammetry. Absolutely, please. And I just have a chance to mention this because I know the time is getting short, but I did dawn in my email to mention that something I would like to really see come out of this summit also is clearer opportunities for how we as instructors continue to learn and continue to develop our skills in ways and be able to participate or collaborate with you all as you develop more and more teaching tools. And I know, for example, Penn State, I don't know about other educators who are out there right now, but for those of us who are been teaching faculty, Penn State is just starting to look at the idea of sabbaticals for teaching faculty. And I think, personally for myself, if I was able to do that, I would really love to get involved, and be able to get integrated and embedded into a group that really has all the resources to produce wonderful teaching tutorial materials. Lend my technical expertise, but also get back, we don't have the resources to make these fantastic teaching products that you all have. So I'd love to see that kind of collaboration, and I'd absolutely like to do it around photogrammetry.
So one of the best kept secrets perhaps at Esri is that we do have a faculty sabbatical program, and we do have opportunities for faculty to spend time with us anywhere from a couple of weeks to a year on any number of these types of projects. And as time allows, I will put the URL to that sabbatical program in the chat so that people can see what is involved there. And Karen, your comment is a perfect segue to the 5 minutes that we have left. I would like for us to use the 5 minutes, and noting also that Melanie Sutton will make sure that your comment for Delphine is delivered directly to her. And for our last question, how can the remote sensing education community work more closely together to indeed take action on these and other items that have been discussed during our closing plenary, but also during the entire conference. And let me emphasize that this closing plenary is a beginning. This is not something where we've had our nice discussion and then we're going to go off to our separate worlds and continue our work. We're certainly going to do that, but this is really to begin a community, to continue this discussion, to build this academy. And so and in fact, one of the ideas that Joseph brought up was that this closing plenary group might do an article or a blog or communicate the substance of what we have talked about here, because it's been so very rich. But what are some ideas that are floating around in your heads, in your brilliant heads, dear closing panel, in terms of, should we create an online forum or a website within Esri? Of course, we should connect with professional societies such as ASPRS, AAG, AmericaView perhaps. How can we best reach out to remote sensing instructors at universities and institutions with links to this summit recording and to new tutorials? What about a mentoring network? And Karen, I believe this was one of your ideas, for aspiring remote sensing professionals who are operating outside of traditional academic environments, or other ideas? Or would you like to say yes to all?
Maybe go ahead, Karen. No, I was just going to start with a small thing from the point of view of the work we started with this website I showed. We definitely want to go on building it. We want to work more directly with some of you educators. Definitely, it can be, in the form of, we do work in my team very regularly with educators that we essentially ask to help us author a lesson. And I believe this is really how to get the best materials, because that's really what's going to fit your needs the best, right? Respond to your needs the best. So we definitely would like to do more of that in the domain of remote sensing. And also, more generally, we are interested in experimenting with various formats, ways of supporting the community, as we really want to help. We realize some of the pain points and some of the challenges, and we are really open to trying things out. I know that in the domain, this is not remote sensing, but more GIS or working with high school teachers. For instance, we've been doing things around peer-to-peer mentoring and fostering a small developing network there. We've also been participating in some pilot programs with some specific universities. So just wanted to say that we definitely are very interested in sort of those next steps.
Wonderful. Thank you, Delphine. Some other comments from our panel?
I just wanted to say, when you said yes to everything, that it sounds wonderful. I guess for me, it's carving out the time. And so it used to be wonderful to go to a conference, ASPRS or UCGIS or AAG, and then you're removed from your home setting. You go to a session, get inspired, grab the person afterwards and go have a coffee, that kind of thing. If we could formalize that somehow, even in a virtual world, I think that would be wonderful to learn from each other.
Mm-hmm. So agree. And I think that's a wonderful point on which to end. And thank you, Nishant, for your comment that you would like to be part of an initiative to develop structured course content and a centralized library for all educators that will be part of these activities going forward. And again, the emphasis is that this is really the beginning of a beautiful relationship. I just saw Casablanca, so I still have that on my mind. If you get the veiled reference there. At any rate, we look forward to moving forward with all of you, and I am so very happy to have been able to moderate this very rich discussion. This was an awful lot of fun. So I want to thank again Jarlath O'Neill Dunn, who had to leave us early, for his rich contributions to the planning of this discussion, as well as starting it off. Marguerite, Madden, always a pleasure. Thank you so much. Karen Shookman, it's been my great pleasure to meet you for the first time. And I'm so very, very glad that you were part of this discussion as well and made it even richer. And my dear colleagues, Joseph and Delphine, always a pleasure. Thank you so much. This was terrific. And thanks also to Jerry Miller and Lori Jordan, who have stood by, who are standing by, actually, in support of this discussion and, of course, of this entire meeting. This has been Lori Jordan's beautiful brainchild for quite some time. So congratulations again. And I will now pass off to my colleague Jerry to close, well, for next steps.
Absolutely. Well, thank you, Dawn, and thank you for joining us again amidst many things happening. And I know you do have to run to another keynote that you're giving in the 12-13 minutes. So thank you for leading us through this wonderful panel discussion. And again, special thanks for our colleagues from the community that were here. So Karen Shookman and Margaret Madden and Tommy Jordan and Jarlath, he went to get his vaccine. But you guys have been phenomenal in terms of helping us craft this event together. So again, special thank you to all of you and all of our colleagues at Esri that were part of this event. So at this point, we we'll share just a couple of next steps. Of course, all these discussions, we're hopeful to, and we'll look forward to continuing all of them. We earlier shared a number of resources, and again, we'll continue to add more and more to that. As we've mentioned a couple of times, the proceedings, all the recordings, the slides, the URLs, they're going to be part of the proceedings as follow-up from the conference. You can always reach out to us. There's lots of folks that are here to help and support your work. And of course, we're already thinking of what's next, particularly for this group, for this Cemetery Summit, as Lori spearheaded it and initiated it 2 years ago for the first time. It was more, only a couple of hundred people. We expanded it, and then we'll look forward to even expanding it more and hearing some of your feedback from this event and what we can do to improve it and to make it better. It would be wonderful. So you will see a survey come after the conference. We'll very much appreciate all of your thoughts, your comments, or just email us and just let us know what those are. So Lori, would you like to add more?
Great, thanks, Sherry. Just to say thank you, everyone, for coming and for the wonderful discussion. And Jerry, thank you especially for your leadership in guiding this very, very engaging event. And as you know, we're already planning to do this again in 2022. So we hope everyone will come to that and be on the lookout for the dates for the Fall Imagery Summit as well. That'll be happening. So again, Jerry, thank you. And Dawn Wright, you can all see why we love Dawn. We're so honored to have her as our chief scientist. So thank you, everyone, for coming. Jerry, thank you for your leadership.
And thank you, Laurie, too.